Good morning, everybody, and welcome to DevOps. Thanks for being here. I think we have to talk to Stefan about the agents are rising thing. I'm not sure he knows Cyberpunk that well, but agents are usually not the good guys. Also, they don't look like the good guys, which aligns with what I see AI agents as, but that's a different story. Let's not talk about that. Hi, I'm Nicolai. I'm a Java developer advocate at Oracle, and I'm here to talk to you about Java 25 and everything that happened in the last 2 years overall. So we will focus on 25, which is out for a couple of weeks now, but we will have time for 24, 23, and 22. And the goal here is to go through all of 25, and then maybe a few things that are going away. Then we're going to take a break, like maybe 15, 20 minutes, so you can all stretch your legs a bit and get a little caffeine refill. And then we go through everything else that we could talk about. We might not be able to cover everything. I'll probably let you decide. So if you see something that you like, feel free to memorize it and then yell it later. The slides are already online, and you can ask questions at any time. I might not see you. Just start yelling. That's fine. I want to answer questions as soon as they arise. OK, so I have some good news and some bad news. The good news is I'm not going to regale you with my whole Java 25 is no LTS version stuff. Just the TLDR here is Oracle JDK 25 is an LTS version, and other vendors' JDKs are LTS versions, but Java 25, the thing, that overarching thing, is not actually an LTS version. It's a semantic difference. You still get support. No worries. If you care about this, do come and yell at me later why I'm saying such stupid things. Also, I will not go through all the upgrade stuff. The reason for that is that upgrading from Java 21 to 25 is pretty straightforward. Yes, there are a ton of small things that can happen, but most of you will see none or very few of those. So instead of teaching a bunch of stuff that could potentially be interesting, but for most people, most of it won't, I'll just point to that video, which contains all the things that can go wrong between 21 and 25. And instead now, we'll get to the bad news, which is this is way too much to talk about. So this is all that we can talk about in 25. And then there's more in 24. 23 is rather slim, so that's good. But 22 also a bunch of stuff. And none of that is preview features, which are all of these. So as I say, there's a lot of stuff to cover, and we'll focus on the 25 things at first. And with that intro, I do want to get going. So let's do that. Let's talk about module imports. So brief question. Individual imports or star imports? Which one do you prefer? Who likes the individual imports? That's, I don't know, like 80% of people, I guess. And the star imports? OK, and then a few undecided ones. OK, good. So if you're in Camp B, this is 100% definitely for you. If you're in Camp A, still, there might be something here that you could ponder. So the upsides of star imports, which is why the few people who are always there prefer them, probably, is because they're more succinct and easier to manage manually, right? Without an IDE, individual imports become very tiresome very soon. The downside is that they are less clear. There can be conflicts, right? Specifically if you include non-JDK classes. But then also, it's kind of like an arbitrary slice through an API. If you import every type in a package, you could get a full API. You could actually get several APIs depending on the package. But also some APIs are split across packages, and then you just get, like as I said, like a random slice of it. May I introduce you to module imports. You say import module, and then the module name. And maybe most importantly, before you zone out, no, your code does not need to be in a module for this. The code that you're importing needs to be in a module, which is true for all JDK code, and then potentially also for your dependencies if you do use modules. And that imports the entire public API. Now, what exactly is the public API? It's all public top-level types that are in a package that is exported by that module. And then there's a few more details here that if you do know modules, you're aware that there's a thing called qualified exports, where a module exports just to specific other modules, and those would be included as well, if you're one of the named ones. And then there's implied readability, meaning a module can basically say, my public API uses types from this other module, so you cannot use me without using that one. And that module's public types will then also be exported to you, right? So with import module, you get the full public API that a module exports. Compared to regular imports, I would say they're much more succinct. They're really trivial to manage manually. It's really easy to just write like import module Java SQL at the top, and then go with that. The downsides is it's again less detailed than the individual imports, and you can get conflicts, although those are rare, and I'll show you how to resolve those. But the cool thing is, it's no more sliced through an API. Presumably, you're going to get the full API that the module exports. You can end up with conflicts. Surprisingly, within the JDK, there are very few. I think it's really only list and date that are not unique class names. Date coming from Java SQL and also a Java base, and then list coming from Java desktop and Java base. Although the date type in Java base, you probably shouldn't use that anymore. If you have the chance, use that date time API introduced in Java 8. And who writes Swing API code, am I right? But still, this situation could occur. And the way you resolve this is like you would resolve with star imports, just import the specific types, and now it's clear and unique which ones you use. Okay, so when would you use this? For all the people who use option A and totally zoned out, welcome back. If you are using star imports, great. But if you're not using star imports, but you might occasionally write something in a different environment than usual, maybe you're writing a demo or you're just trying to try something out, maybe you want to present something on a slide, another presentation, then all those situations are where module imports really work well. And I have to admit, since I started using them in those environments, now I'm sometimes kind of feeling like, why don't I use them more often in like more regular code? Because the fact that now I can actually use imports for anything but scrolling past or having them folded has a certain additional value. Because realistically speaking, if you have individual type imports, as I always had, you're not going to pay too close attention to them, right? Because they're just way too detailed. Anyway, so those situations where I might want to try them. Then we're going to skip the next slide because we're going to come back to that in a different context. If you want to learn more about this, JEP 5.11 introduced module imports as a final feature, and then there's a video about that on the Java YouTube channel, which is going to be a recurring theme. Most of these have deeper dives in the form of either JDK enhancement proposals or a video that we made. Okay, with all that, that's already module imports. Let's do the next thing. Simplified main methods and the on-ramp improvements. So Java is a very mature ecosystem, right? Most of us sitting here have probably worked with Java for a while, for a couple of years maybe, and we enjoy all the benefits that it brings. Like it's a very refined programming model with stuff like package visibility and finality and packages and visibility modifiers and stuff like finality. There's the detailed tool chains. It has a rich ecosystem from many JDK vendors. There's tons of IDEs. There's different web frameworks, different testing frameworks. This is great for people working with it because that means that chances are whatever you need, one or maybe several teams already came up with a solution for it, and you can pick the one that best suits your situation. The downside of that is that as a new developer, you have to figure all of those things out. Again, starting with where do I even get a JDK from? Then why are there several IDEs? And if you've never used an IDE, that's also very overwhelming. And then every step of the way that for us is good that there is choice means for a beginner that they have to make a decision that they're not really equipped to make, honestly. But Java needs to stay approachable, right? We don't want to just have always the same people coming to the conference. Not that I don't like you guys, but still we're all getting older. So Java needs to stay approachable for younger people, for kids, for students, maybe for front-end developers who want to switch to the back-end, maybe for MLAI folks who figure out that maybe running a production app in Python isn't the best thing since sliced spread after all, and they want to change, they want to switch over to Java. So there are many situations where people who've either never programmed, or at least never programmed Java, do enter the Java ecosystem, and we want to make sure that for those folks, there's also a good on-ramp from not knowing a whole lot to at some point being able to really make use of this diversity that we have in the ecosystem. And that can consist of many different things, right? Many of the things that I just mentioned, like for example, I didn't mention build tools, by the way, build tools, JDKs, those things are not touched by these changes that I'm going to talk to you about here. I'm really going to focusing, the features that made it into Java now are really focusing on the language learning part in the beginning there. So let's talk about these three things: simplified main methods and classes, single source file execution, and multi-source file execution. In the past, you had class, main, or class whatever, and then public, static, void, main, string, bracket, bracket, args. That was the minimal class that you had to write, or minimal of code that you had to write for something to even happen. And much of those requirements were removed. This is now final in Java 25. So that means the args parameter, the main being static or public, the class itself, all of those things that you either had to teach somebody new or you have to tell them to ignore, now that doesn't exist anymore. It's not, well, it does exist, of course, but it's not there in the minimal source file anymore. So they can just start with a minimal amount of things to learn or to ignore, and then learn those things as the program grows. So this now is the smallest viable Java program that actually just works. You can use this and run it as is. Beyond that, we finally learned, hey, you have to use system out println anymore. Not only did people make a lot of fun about that for us, also it's really weird that you have this out field, which is a public static field on a class like system, which is something that you usually would never do on your own. It would probably flag in every code review that you ever see that in. So this is just simplified to a new IO class, which has print and print line, also has a cool read line method that just allows you to give a prompt, and then it will just read back what the person entered from the terminal and return as a string. No need to experiment with or to play around with input streams or whatever. So that makes it really straightforward to have a little bit of terminal interaction there. And then that's the slide that I just skipped in the previous segment. You also get an import of Java base for free. So if you use this simple source file, which contains no class around the main method, then you get import module Java base for free. And that means here in this example, I use Stream API, Big Decimal, local datetimes, random generator, stuff that is not here, but also is in Java base, is everything that's file IO related. So there's a big chunk of functionality that's in the base module that you can just start using without having to fiddle with imports, which once again makes it easier to get started. Now, if you have a source file like this, what you want to do with it, compiling to a class file and then running it is a two-step process that, again, doesn't seem really necessary in simple cases, and it's definitely an additional hurdle for beginners. So this has been a feature since Java 11, I want to say. I'm not sure, like for a long time. You can just take a source file and throw it at the launcher, and then it just compiles it in memory and runs it. You've probably heard me talk about this a gazillion times. I use it all the time for all kinds of little code snippets that I need to put on slides, but also, as I said, if I want to show something to people, or just I want to write some code that I then want to put in a gist, for example, self-contained gist, then you can just download the file and run it like this. Now, what's new is that if this program grows and starts being maybe too large to fit into a single source file, you reasonably want to start splitting this up, then you now absolutely can. This is now also final. This project here exists in a folder called myfirstjava, and there is a main.java, there's a helper.java file there, those are source files, and then somewhere we got a library jar. Now, this is one of the still remaining things to be fixed in this story. Where do you get a jar file from? You could download it manually from Maven Central, I guess, but then you better hope that it doesn't have dependencies. So getting jars are still not great, but let's say you have a jar. Maybe you're learning and the teacher provided it for you. Then if you have all this, then you can just go with Java, class path is the contents of the lib folder, and then main.java. And then the launcher will once again compile main.java in memory. It will see there's probably a reference to helper.java, presumably. That's why I guess why it's in the source tree. And based on the package that helper.java declares to be in, which in this case is probably no package at all, so it will be in the default package, so then the launcher will assume, or the compiler will assume that it will find it in the root folder, which is true, so I can compile that one as well. And if either of those has references to a class that it cannot find in the root folder, it will check the dependencies, it will check the class path, and so will find stuff in the library jar too. So this way you can go from a very simple hello world program up to something that can be decently complex. You can absolutely use packages, for example, and all the visibility structures you get there. You can even create a module info source file here. You can use the module path, which makes the -cp and then the quotation marks around the lib /* much simpler. So you can actually build quite, well, depending on what you mean by complex, but for a beginner, quite complex programs. Really, the limit here is when do you want to ship? So the progression here is very straightforward. You start with just like a simple source file and just the main method. And then if you need arguments to express what you want to do, you can add the string bracket args, probably one of the first steps if you're not a little command line tool. If you need organized codes, of course, we can create methods. Fields work as well. So if you have shared state, which is probably not the best idea, just because, I think programming that just looks functional and passes in the parameters and gets out the result is preferable, but yes, you can absolutely have fields. All the JDK APIs are there for you that you can explore, specifically through module imports. That's very easy. You can use libraries. I'm saying simple libraries because everything with a deep dependency tree is kind of troublesome to get. You can split into multiple files, as I said, visibility, package, and modules. And it usually doesn't even have to be that order, right? So you can explore these different, or the beginner can explore these different processes or these different steps in an order that makes sense to the problem that they're having, which I think is the best way to teach. They're working on something when they're realizing, oh, this is a limitation that I'm now having. I think that's the best moment to teach somebody, because then they already understand deeply the problem that they're in, and then the solution really makes sense immediately. As I said, the limit here is when you start to ship, right? And I think that's a very understandable limit, right? You say, okay, as long as you stay on your own system, do all that, that's great. Maybe you share this even with the Git repository with a few other students or colleagues, but as soon as you want to turn this into anything more serious, I think that's the latest possible time where we should consider a build tool. Like, you want to ship something, definitely you should build it properly with build tool, with declared dependencies, with tests probably, which do not show up a whole lot in this story yet. So that means that you can take this pretty far, and all the personal projects that you may run on your system definitely are covered by this. Instead, I started writing scripts like this, for example, to automate stuff on my own system, because I'm not good with Bash, to be honest. Okay, so these are all the JDK enhancement proposals and videos that touch on that. And if you want to dive deeper into that, you can look at that there. Did you have any questions so far? All been very quiet. I'm going to take that as a good sign of attentive listening and not at all fetching up, getting out on some sleep. Okay, let's talk about flexible constructor bodies. So, when you have multiple constructors in the same class, then what they can do is they can each do their own thing. But what I would recommend to do, as long as you have the chance, is to have just one constructor that checks all the arguments and assigns all fields, that contains the important logic, and then every other constructor should just forward to that one. Right? That way, if you want to make sure that the fields have certain properties, there's only one place where you check, and one place where you, for example, fix a bug, and then all the other constructors that you have for convenience will also use that logic. Whereas if you have this logic in different constructors, and then somebody finds a bug and you fix it in 2 out of 3 constructors, then the same bug might come back again in a couple of weeks, which is always the most annoying kind of bug when you're like, didn't I fix this a while ago? So that's why this approach is generally preferable. And this is what it could look like. So I have a class here that has just the first and the last name string field. And then there is a constructor that assigns first and last and does some checks before. But let's say I have a constructor that also takes a middle name that I want to just put together with the first name and the space in between. Then I should do it like this. So I'm intentionally calling the other constructor to make sure that that one does all the checks. And with superclasses, that is even enforced. So if I have a new class 3-part name that extends name that I had before, because now I want to have the middle name as its own field, then I have to have that supercall there. This supercall is something that all subclasses must have in the constructor, although you might not always see it. If the superclass has a parameterless constructor, then super in empty parentheses, with empty parentheses, will be inserted by the compiler by default. So you don't have to insert it manually, but it will always be there in the bytecode. So this kind of chaining is enforced not within a class, but it is enforced across different inheriting classes. Okay, but now the first few wrinkles start to show. If you have a subclass and a superclass, then these two classes need to be initialized in a certain order for all the operations to make sense. And since the superclass doesn't know about the subclass, the idea is that the superclass needs to initialize itself first. So, for example, needs to assign its fields first. And so from that idea came the limitation. Okay, if we need the superclass to do its thing first, then we forbid any code before the call to super. And you've surely been in a situation where you just wanted to do something, though you wanted to have some computation there, and we're going to talk about that, what you could do there, but you probably forced it to like a static method or whatever. Okay, now we have this idea that if a subclass extends a superclass, and by the way, every class is a subclass because everything extends object. So that means every class needs to have a supercall at the beginning of the constructor. Now you can chain constructors in the same class, right? But that also means that if you have a this call there can also be no code before a this call, because otherwise you have call before that this, and then that this ends up calling super, and then you had that code before calling super after all. So the old rule was no statements before super or this. And as a consequence, you will see this kind of behavior. So let's say you have a class A that is extended by B that is extended by C, and then you call new C. What would effectively happen is C constructor calls super, which calls super, which calls super, and then you end up with the code in object, which is empty, being executed first, and then you get the constructor in A being executed, and then in B, and then in C. So what you see is a top-down initialization order, right? Even though you did call new C, what effectively ends up happening is that the code runs down from object through to C in that order. And that sounds great, but can create a few irregularities. So for example, this is a kind of famous example where you have a non-final class name, and then you have the class 3-part name which extends it. And what name does, it thinks, oh well, when I'm done with being constructed, I'm done now, right? I can take my instance and do something with this instance. Here, I'm printing it to the terminal with a new IO print line. What you could also maybe log something, or maybe you're putting it into a map as a key or something. So there's different kind of operations that are not very common, and they're not generally advisable for this specific reason. But what can happen is you expose the instance that you just built to some other code. And the issue with that is, if name is not final, then it might actually not be done initializing, right? So if you look at 3-part name, it calls super, but it still has to assign its middle name. And so if then IO print line is called with this, then it will call toString, right? And the assumption here is that name overrode toString, which is first name space last name. And then whoever implemented 3-part name was like, yeah, of course, our toString is first name space middle name space last name. And so in that chain of events, what you end up with is something like Jane Naldo, which is really not what you called, and which can be very confusing if you see this. And if you now would have used this, for example, as a key in a hash map, you'd be in trouble, because if you, instead of IO print line, put this as a key into a hash map, then the hash would be only the first name and the last name, because the middle name is still null. And then you end up, after you assign the middle name with a different hash count, you'll not find that instance again, which is even more confusing. So while that makes sense, this top-down initialization, it runs into limitations or regularities when you expose an instance too early. And then also, it can be very inconvenient if you want to do something with the arguments that you got before passing them on. If you want to check them or prepare them in some way, if you want to split or share them. So for example, for splitting, let's say I have a constructor that takes the full name as a string, as a single string, and then wants to split on a space. And then probably wants to make sure there's actually 2 parts to that array, but even that, let's ignore that part. And what I want to do is, I want to split and then take the first part and then the last part. But because I can't have any code before the this call, I end up repeating the same work, which in this case is trivial, so it doesn't matter. It feels wrong, but it doesn't matter. But it can also matter, right? If that work is substantial, then it will matter. Now, there are all kinds of workarounds. You can duplicate that, right? The code that assigns the fields. You could, after all, duplicate it across different constructors. You can have internal constructors, so a non-public constructor that takes that string array and then checks whether it has the right length, something like that. You can add static factor methods. And what I didn't list here, because it's not that much a workaround, but can also become cumbersome, you can, of course, have static method calls. Instead of calling a constructor, you have a static, with an argument, you pass something to a static method that then prepares the argument. But if you do that, this is often not what you actually want. You're just writing that static method because that's what the compiler forces you to do. And if it gets too complex, that can also become very unreadable. Records have a specific limitation here. This whole thing of constructor chaining that I mentioned earlier, records absolutely enforce this. Records have this idea of a canonical constructor, a one true constructor. That is the one that takes all the values for all the components. And you always have to call that one. So if you never tried, try. If name were a record, then you could not have an extra constructor that just assigns first and last. Only the canonical constructor is allowed to do that. So, and then again, you have even less options here. What we really want to write is this, though. Pretty straightforward. We just want to split the whole thing and then maybe apply some checks and then pass this on. And also the same for records. And now this is something that we can do. So if you switch to Java 25, this is available to you now. the constructor is now split into 3 parts. The prolog, which is optional, the call to this or super, which is required, but as before, doesn't have to be there explicitly. It can be inserted by the compiler, then you will not have a prolog because the prolog is defined by what happens before the super call. And then the epilog, which is just the normal code that you'll always see. And the prolog, you can do a lot of things, but not everything. So mainly what you cannot do is, you cannot touch the instance under construction except to assign fields. So basically you can think of the prolog as a static context. Whatever you could do in a static method, you can do there, plus also you can assign fields. And now if you have a structure like ABC that we had before, this is what actually happens. So you call new C, and now first the prolog in C is executed, and then in B, and then in A, then we go to object, and then we go back down the same hierarchy for the epilogues. So the second half of that, starting with object, that's the same as before. What's new is that you have the prolog, and that one goes up the hierarchy. So C can put code there in the prolog of its own constructor that will definitely get to run first. And you can do all kinds of things there, right? You can check arguments, you can prepare something, you can split or share something because between different fields or different parameters, and you can also assign fields. So, for example, what you could do is, let's say we have a 3-part name again, the class that extends name, and it wants to make sure that the first name isn't empty, for example. So does this require non-null, non-empty, which is a usability method I wrote myself. It does that check, then it applies, then it assigns the field, and only when it's itself fixed the little bit of state that it can itself control, only then does it pass control flow up the hierarchy. You can prepare arguments like this. So let's say I want to have the first name shortened to a single character if there is a middle name. So we're going to do a few checks here and then do the super call, right? Nothing that is any rocket science. Now we can have the split and only do it once. So if you have something expensive to do, you can make sure it only happens once without any extra circumstances. This is something that is very straightforward, right? Once you've seen it, you're like, okay, yeah, that's what I want to do. So whenever you have logic that you want to apply to the arguments, feel free to do that before calling super or this. And also assign those fields. And I would argue that it would now be considered best practice to do that always. So whenever you extend another class and you have your own fields, check and assign your fields first, then pass everything else onto the superclass. That way, if the superclass exposes the instance as earlier with an IO print line or a hash map or whatever else, then nothing bad can happen because you made sure that at least your slice of the state is properly initialized. And that means by the time that the superconstructor runs, it can do its part and then it's fully initialized. So if it then ends up passing the instance off, it is already done. Now all of that was introduced through Project Amber, which not really set out to do this. Somebody who's such as an OpenJDK member who's not working for Oracle came up with this idea that its limitation is maybe overly strict. And there was a process behind this to figure this out. This feature was in preview for a while, and then eventually it got settled and decided. But it turned out that this is super interesting for Project Valhalla. Now, I'm not have time to talk a lot about Project Valhalla here. If you heard about Valhalla's exploration of null-safe types, then this is where this connects. If this doesn't make sense to you, what I'm going to explain in a minute, then don't worry. It's not for this specific talk. Yes, Mario. Okay, so Mario asks, it's not clear what is not allowed in the prolog. So anything you need this for. So for example, you cannot call an instance method in the prolog because an instance method is actually sugar for this dot call my instance method. So everything you can do in a static method plus assign fields, except fields that have their own assignment already. Like if you have like my field is private final string foo equals foo, then you can actually not reassign that. That's like a little detail. You'll figure that out when you do it. But generally speaking, static context plus field assignment. I can do this dot middle equal to names one, but I cannot call a set middle. Yes, perfect example, right. So Mario observed correctly that if I have a method that is, let's say I have, well, this middle name is final, but let's say it weren't final, and I had a set middle name method. I could not call set middle name here, because that's something that is a method that I need this instance for. I can only assign fields directly. In this case, that could feel like a pointless limitation. Why couldn't I go through the setter? But the Java compiler doesn't generally know that the setter really only is a setter. So that's why you could not call any method here. You could not call toString, for example. You could not, because the thing is, the instance under construction is not done, right? The whole superclass still needs to do its thing. So everything you could do with the instance here is fraught and dangerous because it's probably in a weird half-written state. That's why this whole feature was introduced, to prevent those rare half-done states to escape. And yeah, if you could just call methods here, you'd just make it way more common for these situations to occur. Okay. Back to the Valhalla cameo, null restricted fields. The idea here is that in the future Java version, maybe we can say this field should never be null. But the thing is, so the constructor doesn't actually construct an object. The Java runtime constructs an object which is empty and then tells the constructor, fill the object. So that means all your fields are initially in a situation where everything that is null, can be null, is null. So every string, every list, every integer, private final string equals, private final string foo equals foo is initially null after the instance is created by the runtime and then passed off to the constructor, which will then start to fill the fields. So the problem is, if you have a limitation that says this field can never be null, but the runtime says it must be null at some point because that's how I create it, how do you marry those two things? And the answer to that is, well, is it really null if nobody can ever see it? So the idea is that this will still happen. The instance will still be created with all fields null, but then the constructor must assign values to it. And now it can do that in a way that prevents an instance that has like some of those fields null to be visible to another to another constructor, for example, to another piece of code. So that's where this turned out kind of surprisingly, actually, to be really helpful for Valhalla. And there is a longer talk about that from Brian Getz from last year's JVMLS. That's the one at the bottom there, where he goes through the state of Valhalla back then, which has evolved but not radically changed since then, and where he explains this specific connection in more detail. So if you're interested in that, go check that out. Again, there's another shorter video, statements before the super and this, and then there's a JDK enhanced proposal that introduced this feature. Question, yes? Oh, you mean, okay, so the question is, I think, what happens if there is no supercall, right? Yes. Okay, so if there is no supercall, then you're by default in the epilogue, right? Because Java wouldn't want to break backwards code in a backwards incompatible manner. So the code, if you have just a constructor that just contains code, you're in the epilogue. If you want to have code in the prologue, you need to put a supercall there, which might mean super parentheses, like an empty supercall if nothing else is available. Yeah? So you're saying there can still be an incomplete object if it's exposed, like let's say in, I think you're probably talking about this in this situation, right? So like the question is, can some of those still expose an incomplete object? And I mean, yes, they can. If B, for example, is written in a way that, or rather, let's say in the example that I had in the beginning with the print line here, this situation can still occur, but this class can guard against it by putting this middle here. It doesn't mean it happens automatically, but you now have an option to write code in a way that it does not happen anymore. And that's why I said this is probably, I haven't used this feature enough yet, but this is probably why I'm pretty sure this will turn into just like a recommended default behavior. I don't like the term best practice, but let's use the term best practice here. Well, it's going to turn into a best practice to actually, in this situation, like here, in this precise situation, to always do the assignments before the supercall. To actually change that around, to make sure that no matter what this class does, once it reaches this piece of code, this part will have been initialized. And yeah, if this, also passes up to more code, there can still be misbehavior elsewhere, but you now have a chance to behave correctly. And it's pretty straightforward. It just means I check and assign my fields first, and then I pass control flow up the chain. So what happens if you throw an error, right? So if this one, for example, here, I think maybe even have a check here somewhere in these examples. Let me think. Did we see something somewhere? Here, for example. Right, so this one can absolutely throw an exception. But as always, when the constructor throws an exception, you don't have an instance to work with, right? If you call a constructor and the constructor throws, then there's no instance that you get back to the outside code. So, there's nothing bad can happen. But yes, also, you could probably do that, right? So maybe, although this is not a performance feature, but maybe what the superclass does is kind of expensive. Maybe it needs to do some logger initialization, right? Maybe that can be expensive. Or maybe it initializes a graphics context or whatever else. And then sometimes what could happen is that your subclass, calls a superconstructor, it does something expensive, and then the subclass checks its arguments and realizes, oh, actually, I don't have the right values, and then I throw an exception. So then you throw an exception after you did the expensive thing. And this way would prevent this. Again, don't write this code as performance optimization, but you get this for free, that if you do your checks locally first, then you don't do unnecessary work if an error turns out, if it turns out to be an error situation. Okay, I think I don't see any hands. If I'm missing somebody, as I said, you can just yell, but otherwise I'll go on. Okay, let's talk about scope values. So if you write methods, and I hope you do, then you're probably passing arguments usually as parameters, or the data that they use comes through fields, right? That's I don't know, 99% of the methods probably do that. They read their state from arguments or from fields. But that's not always the case. There are situations where maybe in a frameworky situation where you have certain capabilities that you do want to hide from the user code, right? Maybe a framework passes code or passes control flow to the user code, and then will later come back to the framework, and the framework needs to figure out what's happening, but it does not want to pass sensitive information on. Maybe you have thread-specific data that you don't want to continuously pass on. Maybe you have something like you need thread isolation. So there are situations where you do not pass the stuff on like that, and then thread local is a common solution to use. So for those of you who have not used thread local a whole lot, this is what it will look like. So it's very common to have a private or maybe even non-private static final field for the thread local. And at first, this thing is empty. So if you call a get on it, it would return null. But here, I'm then calling set, and then I'm printing what I can get from the answer, which is 42. And I'm doing the same thing down here. But in between, I started a new thread and called get in that thread, and that will return null because thread local isolates, by default, isolates data per thread. Okay, so what we get here is a chance for our code to set some state and then let the control flow do whatever else. And when it comes back down here, I can still read that state, but that state is different per thread. So a new thread that is launched will by default, you can have an inherited thread local, but will by default not see the same thing. And that is something that is not that common, but it does exist. And if you need it, it's really handy that it's there. The problem with this is that while it works, it's not the best program model for the majority of cases. It has too much flexibility, so to speak. So first of all, you need manual cleanup. So in this previous example, this thread local that held the data 42, that will be there until that thread dies or until I set a different value, as I set null, for example. If I don't remember to do that, I can have very expensive data, meaning not expensive, which keeps a lot of the heap alive. I can still have that referenced. So let's say I'm working on a thread pool, and one thread does something expensive and puts it to a thread pool, but forgets to take it back out of, puts it to a thread local. but forgets to reset it, then that thread will eventually go back to the pool, will continue existing maybe for the rest of the lifetime of the application, all the while holding a reference to the thread log to this large thing that I built that will then always be referenced and never get garbage collected. For example, that's something that could happen. There could also be sensitive data that I do not want to stick around. This calling set that I did on the previous slide, you can do that everywhere in your code. So who writes this value and who reads this value is not easy to see. You have to analyze the entire code to see that. And so you get into global mutable state here very quickly, which is not great. And then, because it is mutable and it is thread isolated, that means if you inherit this data to a new thread, so if you say, okay, I have, let's say, a thread local, and now I'm starting a new thread, and then you can make it so that that new thread can also see the same thread local. It starts with the same data, but since the data should be continued to be thread isolated, it needs to make a copy. So that initially both threads see the same, but if one of them changes it, the other doesn't see the change because it's thread local, right? So this inheriting of data, this initial copy that they get, needs to be an actual copy. And if it's a lot of data, the data itself isn't copied, but the references to it. If it's a lot of thread locals, that can get expensive, although that is not very common. And scope values are a new feature that address all that. They look... Yes. So this last point is something that is especially relevant for virtual threads. So the idea to, well, if I create a new thread and I copy all of that over, how expensive can this really be? Well, the answer depends on how many threads you have. And with regular threads, where you have probably in the order of thousands, maybe tens of thousands, but probably not more, that is a much lower risk of running into problems than if you have virtual threads, which you can turn up the number basically arbitrarily. So that last point becomes more relevant for virtual threads, which was surely like a big reason to explore a better solution. Okay, this is what a scope value looks like. Initially, very similar, scope value, new instance. And now the way you use it is different though. You write scope value, and then you call a static method where, and then you say where the answer is 42, so 42 becomes the value, that's where I want you to run this thing. And this run method is the scope. Everything within that run method, or everything that's called from there, everything that's called from that lambda, so potentially your whole application, is in the scope of this scope value and can read 42. Right? So this one can just get 42 and that will work. Note that this is not a separate thread. Right? There's no threading involved here yet. I'm just saying execute this lambda, like right now, on the same thread, but what it means is that this is within the scope of this value, so I can totally read the 42 here. And as soon as that scope ended, if I call get, I get a no such element exception, because it's out of scope. Compared to the thread local example, that is more usable in the situation where it applies. So the data is only available in run, and the data flow is one way. Right? You set the value, and then the code that you call in run can see that value, but it cannot set the value. There's no two-way communication here. And since nobody can reset the value, you also don't need to create a copy. So if you have child threads, and we'll see later how that works, if you have child threads that work with this, then they can all see the same memory location, because that can never change, and that way you don't need to make copies. And if you have millions of virtual threads sharing inherited thread locals, that can potentially become expensive. If you have millions of virtual threads that all share the same scope value, you'd only have the one scope value instance, so that's basically free. Now the limitation here is that you cannot have this two-way data flow, right? So if your application depends on that, or if your use of this API depends on that, then scope values are not a replacement. So that's intentional, right? As I said earlier, the majority of use cases don't need that, but they still pay for that flexibility that they're not using. So scope values is done for those cases where you do not need this flexibility, and then you get a bunch of upsides. But yeah, if you do need the flexibility, then thread locals are still there for you. And probably obvious, but I didn't explicitly put it on the slide, the data cannot linger, right? After the scope is done, the data gets removed. That's why you get the no such element exception, so no manual cleanup needed or even possible. What you can do, though, is you can rebind stuff. So rebinding is a little bit weird, but it makes sense if you think about it. I have this as a setup where I once again have this answer scope value here. And then I have a method A that binds 42 to that scope value and then calls B. Again, just to make sure, no threading is involved here. Because I've used the word threading before, and this is a run method, you might have this association. But there's no threading. This just calls B, and then B can absolutely read the answer, right? Because it's in the scope. It's called from A. So that's good. This can read 42. What it can do, though, is it can rebind the value. It can say, OK, I'm creating a new scope. In my own scope, I'm creating a new scope. And in my new scope, I'm setting a new value. So this one says, I want to call, well, this would end up being 43. I want to call C with 43. And then, C gets executed. So we're going to see that 42. Then we're going to do this, which prints this 43. And then outside here on this scope, we're outside of the new rebinding scope. So we still see 42. So you can rebind, basically nest these scopes, but there's still no two-way data communication. So just in case this is necessary, or you need to do something like this is entirely possible. But again, like it still stays as immutable one-way communication. Question, yes? Yeah, what if a mutable structure like list? So I used 42 here. What if answer.get returns a mutable structure? Yes, that's also the same for thread local, by the way. You can absolutely do this. So you can put mutable stuff in there, and then if you inherit that across different threads, good luck. So this is not magic. Like it doesn't like make stuff magically thread safe all the way down. It just gives you the chance to have thread isolated data. But and you might actually want to have mutable stuff there, right? Like maybe you do have, maybe your threading works in a way that you have a bunch of threads that are logically grouped, and one group works on one data structure, and the other group works on another data structure, and you later want to combine that. So this can actually be viable. It just means that then, yes, you have to then pay attention to make sure that the data structure there is still thread safe, or you treat it in a thread safe way. Yes? So you're saying here, so let's say this takes an integer parameter, and here I say run, and then opening, closing parenthesis, arrow, C with answer.get. I'm very sure that will be 42. I haven't tried that, but the reason I'm saying that is that this call here is not in that scope yet, right? Like if you would think like how are parameters resolved, you would also think it happens on the outside. Oh, if you just give the instance. Oh, you just, okay, so you don't call answer.get, you pass answer, the instance answer. Yeah, that doesn't make a difference. If you call, the question is where you get this instance from, whether it is like in this case, a static final field, or it's passed as an argument, that doesn't matter. So it doesn't matter where you get this reference from. Okay. Inheritance. Did somebody? Oh yes, in the back. Yes. Sorry. To get an identifier for the scope? No. I mean, you could build something, I guess, right? But there's, you know what? Maybe put the identifier in another scope value. I'm not joking. Like maybe if you need to identify, there are ways to build it, but by default, no. Okay, let's talk about inheritance. As I said earlier, because scope values are immutable, as long as you stay within that scope, you don't need to make copies, right? Because you always the data cannot change. And structured concurrency is inherently scoped. Now, if you don't know exactly what that means, that's okay, because we're going to talk about structured concurrency, which is a preview API later in the session. So we're going to revisit the next slide later when you know more about structured concurrency. I didn't know from which end to make this connection, so I made it from both ends. So for those of you who do know structured concurrency, this will make sense now. For those of you who don't, it will make sense later. So the idea here is that structured concurrency also creates a scope for its own threading. And that means that the tasks or threads of a structured task scope can inherit or will by default inherit scope values. And only this is the only way how scope values can inherit to several threads. So this is what that could look like. So I have scope value where the answer is 42, and in this run method, now for the first time I'm doing something interesting, which is I want to create a structured task scope, fork a few tasks, wait for them to complete, put together a result and print it. And now I did some ASCII art that shows the scopes. So the scope value scope runs from all the way up there to all the way down here. So that's the outer bracket. That's where the scope of the scope value runs. And because of the way that structured concurrency works, we know that all the child threads that I launch here will be done by the time we get to the end of this try block. By the way, I just realized now this code will it compile? I don't think it will compile, actually. Let's ignore that. The reason why it won't is because this will still throw into an interrupted exception, an execution exception, and this would be a runnable. If I put a return void here, it's a return null here, it becomes a callable. Anyway, don't try this at home. The point is that all the child threads that are launched here will be done by the time I reach the end of the try block. And that means that their scope is necessarily contained within the scope of the scope value. And that's why we can inherit those values, or scope values can inherit their value to these child threads without any issues, without any further ado. So this happens on its own automatically. So if you want to use scope structured concurrency and scope values, they will collaborate seamlessly with one another. Okay, slight compiler errors aside, I hope that makes sense. Again, if you don't know structured concurrency that well, we're going to have another segment on that later. Okay, another JEP, another video for details. Okay, let's talk a little bit about ahead-of-time computation and making your applications launch faster. Generally speaking, Java has really good peak performance to the point where it absolutely rivals the... Oh, question, yes? Uh-oh, okay. So the question was threatened to be very specific, but I'll try my best. Yes, go. Mm-hmm. Yeah. So the question is, basically, I have a good reason to pass data back. Is that possible at all? Now, when I said data flow is one way, I think I need to work on my phrasing here. Because, again, like it's the same question as what about if I have a mutable structure there? That only applies to what you set to that specific scope value. So on a thread local, you can call set from everywhere. So you would, if you have like a login context, you can always set a new login context. And that's something that scope values do not allow. You say, okay, where this scope value has this login context, this specific instance, run this code. But that instance can be mutable. So that instance can absolutely be mutated in downstream method calls, and then the top side can get that instance and look at it, right? Because it's no magic. If you have an array list as a scope value, every code can just add and remove stuff from that array list. So when I said data flow is one way, I really meant only as far as the scoped value is concerned. It does not allow to reset its own value. But the value itself, if you mutate that, sure, go ahead. Okay. Good. Ahead of time? Let's do ahead of time. So Java, good peak performance, but slow startup time, slow warm-up time. These terms are not generally defined, but Project Leiden, who works on this stuff, make the definition for their work. And here startup time is from you tell the launcher to run your application to it does the first useful unit of work. If you have a Hello World app, the first useful unit of work is IO print line. If you have a web server, then all of the web framework launching and the web server launching, and then once you can handle the first incoming request, that will be the first useful unit of work. So the first useful unit of work always includes the entire JVM startup plus potential application startup if there is any. And then warm up is from that point to peak performance. Now peak performance is even less well defined than first useful unit of work, because it's not like the JVM tells you we reached peak performance, I'm going to go to sleep now. Like it's constantly observing your code. It constantly looks for places to optimize, or also maybe then de-optimization is necessary, right? So there is no one point. But if you look at performance graphs, you can, I know it when I see it. You can see, okay, like this is when it starts to level off, and from here on out, the performance is stable. So startup, launcher to first useful unit of work, warm up is after that. A lot of stuff happens in that time frame. Class loading, call side linking, constant pool resolution. First, your code runs interpreted and is observed, and then just-in-time compiler kicks in, and just-in-time compiles a bunch of stuff after gathering some profiles. Ideally, we'd want to do all of that, like just all of it ahead of time. But like if all of that could happen before you launch your application, then the application can just launch and just be fast, have peak performance from the get-go. The reason why that has not happened is not just because all my colleagues are very lazy. It's also, don't tell them I said this. It's also because, or mainly, they would argue mainly, because Java is very dynamic. We think of Java as a static language because static and dynamic is often used in the context of type systems. Yes, Java has a static type system, but that's almost where Java's static nature ends. It is very dynamic in nature, right? So for example, something that is totally normal for us that in other ecosystems is not at all normal, you can just take any jar and throw it into every application, and as long as the Java version requirements are fulfilled, it will work. No recompilation of the code using it needed, right? That's very dynamic. You don't know what exact classes will be loaded while you write your program. Nobody knows until you actually start the program. So class loading, then agents could redefine this. What methods, how methods are linked depends on how many implementations, for example, of interface there are. Access control plays a role specifically with modules. Then there's so much more or less runtime type checks that need to happen. You can use reflection, which is very dynamic in nature. The just-in-time compiler does stuff. So given all of this is very dynamic and is only really discovered at runtime, how could we do anything ahead of time? And ideally, we just have a crystal ball and look into the future. Ideally, at build time, we'll just see the future of what will happen when we run, and then with that knowledge, do everything now. Now, we don't have that yet, we're working on it, but until we're going to use training runs. So the idea is you take your application and you do a training run, which hopefully resembles your production run very closely. That information is gathered, and then that information can be used to create an AOT cache. If you heard about class data sharing and the CDS archive, this is an evolution of that and has a very similar workflow. Project Leiden introduced this. The idea here is, as I said, you observe the JVM in a training situation. You capture all the decisions that it, or a bunch of decisions that it makes, and put that into this AOT cache. And then when you run the production run, you use this AOT cache as the initial state. Now, importantly, the JVM still does its thing. It will still do the regular work it does and will discover when the cache is faulty and can then invalidate the cache and do something based on the real observations instead. That will then in some cost you performance, but it definitely will not lead to bad results. Generally speaking, this is the workflow. You don't have to look at this command line flags in detail, it doesn't matter. But the important part is we have a training run first where we launch the application and tell the AOT mode to record something. Then we have an assembly phase where we do not launch the application. We just give the class path and say, please create the cache. And then the production run is like the normal production run, whatever you do, but with this cache given. So this is this trifecta. Training run, assembly phase, production run. There will be ways in a minute, there will be ways to shortcut this. There's already one shortcut now, which is does the training run the assembly phase in one step, because in most cases where you don't need like specific command line options, this will just work. And maybe in the future, there will be a way where you just launch the application without a cache and then tell it, just do your thing. And if you shut down successfully, meaning not do an error, then create a cache after and write that to disk. And then maybe you could just do it in one step. That is not there yet. I'm not sure whether that will happen. But ergonomic improvements are definitely something that is being looked into. Yes? How can you use it in containerized environments? That depends a little bit on how exactly those are structured. If you like, the best training run is something, as I said, that closely resembles production, which means the best training run is actually production. So if you do something like canary deployments, that is really great, right? Like you take the new version and just put one instance out there, you observe it, and you also take that opportunity to create all of this profile data, and then you can create the cache from it, and then choices are you can include the cache file in the Docker image, but it's always exactly the same cache file. You could also put it on something like a persistent volume and link that into your images. This is the cache file, yes, this app.aot, this is the cache file, yeah. You can transfer it. Is that a question? Yes, yeah, it's like it's a regular file. You can either have that in the image or you can like maybe link it into the image. Yeah, I'm gonna come to like actually on the next slide, I'm gonna tell you a little bit about what size to expect. Okay, so far I've been very vague. So what does actually go into the cache? And this is what is continuously being expanded. At the moment, we have two things in there. The first one is class loading and linking. So improve the startup time, remember, until the first useful unit of work, by making the classes of an application instantly available in a loaded and linked state when the hotspot JVM starts. So what it does is it will load usually it loads when the JVM launches. It loads the bytecode from your jar files, and then it verifies that that bytecode actually fulfills the JVM specification, doesn't do crazy stuff. And then it puts it into an internal data structure. And as long as the classes don't change, that's always the exact same process, will always the exact same result. So this is something that can be done ahead of time. And for the Spring Pet Clinic, for example, you get a roughly 4% startup time reduction, and the cache will end up being 130 megabytes. Now, the Pet Clinic isn't exactly tiny, but it's also not large compared to any real production application, right? So you can expect more classes to end up in there in your code, which will increase the cache size. Something else is method profiling. It's the second thing that is in JDK 25 in AOT cache. So improve warm-up time by making method execution profiles from a previous run of an application instantly available when the hotspot Java virtual machine starts. So the idea here is that the JVM observes your methods to see which one is worthy of being optimized, and then once it's done that for a while, the just-in-time compiler kicks in. Because otherwise it doesn't know what to optimize and how. These profiles can be put into the cache. So that means when the application starts, then the just-in-time compiler can kick off immediately and start doing its work immediately. They had, this is a different benchmark, right? So it measures something totally else, has about 20% time reduction in this loop and increased the cache size by a few percent. Now these performance numbers, I only give them to you so you can look at them and think, if I get similar improvements, is it worth the effort? Right? If you're looking for any percent that you get better is good, great, then definitely try this out. If you're saying, no, I need like 99% launch time improvements or it's not worth the effort, then these features are not for you yet. I'm not sure whether Leiden will get to 99, but I'm hoping we'll get to 90 at least over the next couple of years. But that's just my guesswork. Point being, take these numbers, not just with a grain, but like with a bucket of salt. Just see, like, is this something that seems interesting to me, and then try it out yourself. There are a few limitations. And as I said earlier, otherwise the cache is ignored. The limitations are very reasonable though, so you need to use the same JDK release on the same hardware architecture, on the same operating system. The class path between training and production must be consistent. What exactly that means, read the JDK enhancement proposal that uses this. The module options must also be consistent, also same limitation here. Basically, what you cannot do, you cannot radically change the class path of the module options because that will change the other processes that happen during training. And JVM TI agents are limited. Specifically, they should not redefine, or they cannot redefine bytecode. But if any of that happens, you just don't get the cache benefit, which means you put in a lot of work, and then the VM starts, notices, oh, that's not useful to me, and then just discards it. So that's not helpful. Upcoming features are class data caching for any garbage collector. At the moment, I think only G1 is supported for some of that part, for some of that cache, some of the data in the cache, and then maybe code compilation. So this is not a JEP yet, but it looks like it wants to be one soon. This would mean that the results of just-in-time compilation could also be put into the archive or into the cache. And that means when the JVM launches, it can basically look at the profile data and say, oh, I need to optimize these methods, and then look into the code cache and see, oh, I already have those optimizations, and then can take them and use them immediately, which would make the path to peak performance much, much shorter. If you want to learn more about this, I have not only a bunch of JDK enhancement proposals for you to read, but also a talk by my colleague Anna Maria Miacianu and Spring's Moritz Halbritter. They're going to be Thursday in room 6. Talk about Project Leiden and specifically in the context of Spring Boot. See some of you taking out your phone. I will later have a list of all the talks that connect to something I said here. So you can totally photograph that now, but also later then. So if you want to have follow-up talks that go deeper, you can do that there. Yes, question? Oh, you're asking about, okay, you're asking about password or specific data that's different between training run and production run. Yes, what's important here is the behavior of the application can of course be different, right? So what it reads from the file system, what environment variables are set, what the actual requests are asking, all of that can be different because what is stored in the cache is not actually the data of the application. It's the data that the JVM has about the application, right? About your code. All the things that the JVM does to make your code run. That's what goes into the cache. For now, there is no, it's hypothetically possible, but for now, there is no idea to include, or no publicly available plans that I know of, to include something that your application has as a password or whatever else in the cache. So for example, a password would not even show up in the cache unless you have it as a public static final string variable, because then it's in the constant pool. But other than that, no. Right, so the behavior of the app does not need to be identical. The only reason why I said it needs to be close to production is because the JVM wants to observe what your application does and then store part of that optimization information, right? But if your training runs are entirely different, it will just gather profiles in the wrong way. And then we'll launch the application and say, like, oh, it looks like this method should be optimized this way. And then it will take a couple seconds or maybe even minutes to realize, no, wait, that's not actually optimal. And then it has to go to the other way, right? So the closer training run and production run are together, the more benefits you will get out of this. But this is not about the data that your application accrues. Mario had a question. I also saw your question there. Yes, you first. Yeah. So the question is, if the programmer knows these kinds of optimizations will happen or are supposed to happen, can they put this information to the code maybe or into the jar somehow? I don't know, but I want to make a guess that I'm pretty sure that no. The main reason for this is that what and how the JVM optimizes evolves over time quite a lot. And my understanding is of the people within the OpenJDK community, if they look at other languages, they explicitly identify those like speed up keywords, performance keywords as something explicitly negative that they do not want to emulate. We do not want to, or they do not want to have stuff in there that exists just as performance signal, because if those signal changes, then that language or annotation or whatever feature you build now becomes at best useless, at worst actually misleading, because you might then be forced for semantic reasons, maybe to still treat them in some way or other. So I'm pretty sure that that's not on the table. Yeah, for the exact reasons. Also, the way the JVM optimizes also depends on the underlying architecture of the hardware, right? So the idea behind write once and run anywhere is, even though we don't have desktop applications anymore, is still alive, right? You want to write a library that runs performant on all kinds of systems, And that might mean system-specific optimizations that, for example, the library author could never foresee, specifically not into the future. And the question back there? Can you combine this somewhat native code generation? So at the moment, no. The idea is that this code compilation at the bottom will basically lead that way. But the idea here is not to create something like native image. At this point, when Project Leiden started out, the idea was, okay, let's do optimizations. And then you have something like native image, which has a huge amount of optimizations, but also has certain limitations on what you can do. And then what Project Leiden initially said is we're going to have something like condensers. The idea was behind a condenser is you as the person who runs the application are willing to give up certain parts of Java's dynamism in the hope that that gets you better performance. And so initially that was like, okay, let's do that, right? But then when they started exploring, they realized, wait, there's actually quite a lot on the table that if you actually really set your mind to it and have a team work on this diligently, that you can make a lot of improvements without any of those restrictions. So at the moment, Leiden is exploring how far can we push this without any limitations. And then I'm pretty sure over the next couple of years, we will see to what kind of improvement that leads. And if that improvement is substantial enough for the vast majority of projects, my guess is it might actually end there. If it turns out we don't get far enough, so many projects would benefit from more, then yes, maybe we need to look into accepting certain limitations for more performance improvements. And if that road is taken, then maybe at the very end you have something like native image. But I would not guess or bet on that at this point. There was somebody else behind you first, yeah? Is it possible to build the cache from multiple training runs? I'm not aware of any way to merge the profile data, right? Because first you create the profile, and then the cache is built from that profile. What you would need is multiple training runs, and then combine that into one profile. I'm pretty sure that does not exist. I'm also doubting whether that makes sense, because surely these profiles would at least partially contain conflicting information, and it's then not clear which information is better, right? So let's say, for example, in one run, one method was used in one context, so it would be inline that way. By another way, the method is used in a different way. It would be different. It would be optimal to inline in a different way, or optimize in a different way. Then which of those is better? You might maybe know, but probably not down to the level of methods. So I don't think that that's feasible, but that's just a guess. I think I pointed out. Not sure whether Anna could answer that either. You can try, but also we have the Ask the Architect session, and you could totally ask there. Yeah. No. So this is not about. There's no data in this cache. This cache does not contain application data. It's just the data that the JVM has about you. So it's, for example, like the stuff on the heap. It's not in the cache. It's just like the class data, the profiles, all of that the JVM does behind the scenes. There was another question there. Oh my, this topic is, my explanation is bad or the topic is interesting? Yes, go. Sorry, can you repeat that? Oh, does it matter for how long you keep the training run? I mean, kind of. Like, you want your training run, as I said, to look like the production run. So if your production run is basically one hot loop, then all you need to do for the training run is make that loop very hot. That probably just takes a couple seconds, if that long even, right? But if you have a big web application that does all kinds of different things, then you might want to make sure that you hit all of these endpoints sufficiently frequently that you can actually get that improvement. A rule of thumb, if this thing is important to you, you probably have performance benchmarks to look at. You probably have a way to understand what's the performance of your application. So you probably know, oh, it takes like, I don't know, 150 seconds before it reaches that peak point where it levels up. Then the training run should probably be that long to capture all of that ramp up. And if that takes like 5 minutes for your application, make it that long. But if your application is like performing well after a minute, I don't think there's a point in letting the training run longer. Yes, absolutely. For training run, you need load. Like, I mean, unit tests can do that, and don't get me wrong, it doesn't have to be like actual literally run the thing in production with production-like data, but that is probably better, yeah. That's why canary deployments are the ideal situation, because that is real user data on a real application instance. I think I saw more hands though. Yes? Yeah. Okay, so if I understand you correctly, I know you didn't get asked the question, but just to recap, you're saying if you have a CPU-intensive task and you observe with GraalVM that the peak performance, you didn't reach the same peak performance. Is that what you said? Right, so there is no reason to believe that if you use an AOT cache, even one that is faulty or has weird profiles, you will not eventually end up with the same peak performance. Because it's still the same hotspot JVM that still does all the same things. All the AOT cache is doing is giving it a head start. It's basically saying, look, I know they're going to do a bunch of work. Here's that work already done. But it doesn't take away from the actual decisions that are being made at runtime. So whatever happens on the way to peak performance in your application will also happen with the cache. Just ideally, many of these intermediate steps and results will be taken much faster. So you should definitely end up with the same peak performance here. Yes, one in the back. Yes. Is it possible to observe the AOT cache? Yes. I don't know the exact details, but look into JDK Flight Recorder. I'm pretty sure it contains events for that. Or in case I'm wrong, try the -x log option. I'm not sure we have used that before. That was introduced in Java 9 and basically is a new way to configure all kinds of logging about the JVM, not your application, but about the JVM, about what it logs and what information you get. And I think there's actually, because you can key by subsystems, like for example, I want to know class loading, I want to know about garbage collection, I'm pretty sure there's something there. So yes, you can definitely observe this with either xlog or JFR or arguably probably both, I want to guess. Okay. Good. Let's do one more thing, and then we're going to take that break. Okay, compact, oh, actually it's not just one more thing. Compact object headers, let's go. Okay, it's again a performance improvement. And this one is about something that happens under the hood in the JVM. So for every object that runs around on your heap or sits around in your heap, the runtime needs to track a bunch of information. The garbage collection system, the garbage collector needs information on that. The type system needs to know, for example, what instance is this actually, so you can call a method on it. There's still in Java, not still, there is global locking with synchronized, for example, which is the object monitor that is on there. And then the identity hash code, so it isn't recomputed every time you need it, is also burned in there. This is not the regular hash code, the identity hash code. Also, recomputed was the wrong word, because I think it cannot be recomputed reliably. Once the identity hash code is computed once, it will always stay the same, and it's put into the object header. So yes, all of that, that's what I was leading with this, is in the object header. So you have your data, and in front of that is a little bit of data that is all of this. And this is what it looks like. The details don't matter very much. The important part is there's 96 bits here in this example. So on 64-bit hardware, you have 96 bits, it's like 12 bytes used for this object header. And it is what it is, I guess, but it's not great. It turns out that the average object on most applications is actually pretty small. 256 to 512 bits is usually the range in which most objects exist. And now if you add to that the 12 bytes that I just mentioned, this is a sizable portion of this, right? And that means that on many workloads, anywhere between 15 and 30% of your heap is not actually your stuff, it's object headers. It's stuff that the JVM needs to work with your stuff, but it's not something that you're primarily interested in. The problem here is, I mean, it would be great to optimize that, right? Like, it would be great to just like reduce the size here. The problem with that is that all the subsystems I just mentioned, as you can probably imagine, are non-trivial, and it's really important that they are fast and correct. You do not want to get a smaller heap size for, oops, locking doesn't work all of the time now. So this makes it really challenging to explore this. And like I already skipped a thing that's happening here. This is already a simplified version. But thanks to Project Lilliput, this is now available in JDK. So now the header is reliably just 8 bytes. And again, the split of the bits isn't that important, but it's fewer bytes, right? That's the important part here. And this has several downstream effects. So locking operations used to override part of the header, that no longer happens. The class word is smaller and coded differently, and the GC forwarding operations became more complex. And that means that while this is an improvement, it also comes with additional computation that might happen at runtime. And that means in some specific cases, this optimization might actually not improve performance, right? So you're basically saying, okay, we try to compact this information. We're paying for this potentially with more resource use at runtime than we're making up. Now, benchmarks are looking really good. So SpecJVB 2015 benchmarks, which is what JDK uses a lot, recorded less heap space, which is great, but also less CPU time, which is not immediately obvious, because I just said we make it smaller, or it was made smaller. I'm just talking about the stuff, I don't do anything. So it was made smaller, but that comes with a different computation. True, but what you get in exchange is, for example, more cache locality. Right? You get more compact data, you get less GC work, potentially. And that can not only balance out, in most observed cases, it actually comes out ahead. So that's why you have less heap space, which is the primary goal, but also less CPU time, which came along for the ride for the reasons I just lined out. The garbage collections are reduced. There's a JSON parser that was used. All of this green stuff is links that used less time. So there are improvements in various benchmarks here. And you can try this out for your application, which I highly encourage you to do if you do care about a heap size and this kind of performance. If you think like, oh, 5 or 10% more, that's relevant for us, then do try this out. The flag is -XX : plus use compact object headers. And if you do try this out, whatever is the outcome, even if it's just, yup, all works, please report back to the Hotspot Dev mailing list. Like the best way to contribute to OpenJDK, the best way to help Java move forward is to try out features in this preview phase or in this default off phase, in a phase before they are set in stone and always active. Try them out and report back your results. And this might help improve performance, specifically in those edge cases. And the question is, will this become the default? And will this maybe even become the only mode? Because as you can imagine, having all of these subsystems operate on the larger header and on the smaller header is just a lot of extra code that could potentially be kicked out if this becomes the only mode. So please try this out and report back. I should briefly point out, these things don't mean anything to you, that's fine. But just if they do mean something to you, you need to have compressed class pointers on, which is the default, and stack locking must be disabled, which is the default. If you divert from the default in any of these two settings, then compact object headers won't work for you. Okay. JDK enhancement proposals and a video on that. Questions? Yes. I don't know. I'm not aware of any benchmarks that are worse. That doesn't mean they don't exist. But I would guess they don't, because I don't think OpenJDK is in the business of hiding information from us. But yes, but that's exactly interesting, right? Like if you try this out and you realize, oh no, but for me the performance is worse, that is actually interesting, because then maybe, you know, especially people like on these mailing lists, if you can bring useful information, they will be haunting you to try to figure out why. And try to be like, okay, so why is it that case, and what can we still do, right? Is this an edge case that just didn't materialize in other observations that can still be fixed? Or maybe it's inherent, right? Maybe that means, okay, it cannot become the default, or maybe it cannot become the only mode, right? Just like there are trade-offs between garbage collectors, maybe we end up in a situation where there's one solution that is better for most projects, but for other projects we need this other option too. So that would definitely be an interesting observation. And I saw another hand earlier, somewhere there. Yes? Yes. The question is it safe to use in production even though it's experimental? It is safe to use in production. There can always be bugs in anything. But if any misbehavior pops up, it's definitely a bug. This is not, it's not like, oops, like we know it's only working 90% of the time. This is intended to work perfectly reliable like everything else in the JDK. If something does not work, then report it back. But yes, so this is production ready, it's experimental, because it's like it's still early, right? Yes? That is true, yes. Okay, just to recap for the camera. There might be edge cases where the performance improvement is not there, or it could even get worse, but I'm not aware of any such edge case, yes. Like for most, like this is the same with the AOT cache. For most projects, just like the regular everyday performance improvements that the JDK brings, which I'm going to get to in a second, is good enough. And so most of those projects probably don't care too much about this in detail, and also often not in a situation to really measure this reliably. Because if you do go into the business of, we have to figure out what makes our application faster, whether it's garbage collection or flags like this, or code optimizations, or the AOT cache, or whatever else, you need to have a reliable way to measure it. And that is not that easy. But if it's important to you, then your project should set up a way to measure that. And then you're in a situation to just try these things, right? And then you will see whether it works for you or not. Okay, I have a few more things that I had to put 3 dots here that we're not going to have any time to dive into. I just want to mention that since Java 21, we not only got like big improvements of big APIs, we also got a bunch of small stuff. So I'm going to just leave this here for a second to let you meditate while I take a sip of water. If any of that looks important to you, you should totally give it a try. Okay, you done? Then general performance improvements. Every JDK release, as I just mentioned, just does stuff that makes things faster. So if you compare to Java 8, a lot has happened. So again, the spec.jvb benchmark here, this specific measurement, critical max JOPS, I don't know what that means. I was told it's very important and very hard to get an improvement. Did a big jump over 8, but also 25 over 21 is still a 5 and or 10% respectively improvement. There was a benchmark that the team did on Helidon, which has like a 75% improvement of requests per second. Just again, the takeaway here is not, Nicolai promised me I get 75%. The takeaway here is things get faster. It's worth updating. Even, this is just from running on 25, by the way, right? Like this is not, I have to change code or I have to recompile. It's just take your application as it is, lift it over to 25 and run it there, and you get better performance. And for those of you who run in the cloud, that usually means smaller cloud builds. Yeah? No. This is just with none of that. This is just out of the box improvements just because the JVM is getting faster. Yep. JDK flight recorder also got better. So if you do observe your application specifically for performance, you can expect a bunch of improvements. Cooperative sampling is just something under the hood that makes the sampling results more realistic. It can now time and trace individual method calls. And CPU profiling is still experimental. CPU time profiling is still experimental. But that will let you usually it measures walk clock time, which means it's easy to identify operations that are potentially long running. Whereas with CPU time, you can identify operations that are intensive on the CPU core, which might limit, for example, the amount of parallelism that you can employ. If you want to go more into that, Billy did a video about that on the Java YouTube channel, so you can check that out. And I do not want to forget mentioning security enhancements, because while all security vulnerabilities that are detected, that are of sufficient priority, are always fixed in all JDK releases that are still being maintained. So that's not about that, right? Like everything that is a performance vulnerability, security vulnerability, as I said, will be considered and to be fixed. So for that, you do need to stay on your major update, on your major version, and make sure that you always run the latest of that. So for example, 21.0, I don't know what the actual number is, 8, 10, whatever. If you're running on 21, you should know. This is not what this is about. You always get those. What comes with new Java versions is just features that are built on top of that, right? So for example, security configurations got easier and better. You can now have includes, for example, in security properties files, so you can split complex configurations across several files and include them. Java is taking the way toward quantum-resistent cryptography, which is important because legislations do start to declare deadlines at which point projects will be forced, at least projects that work usually for public institutions, to use some quantum-resistant cryptography, because what is already happening, very likely at least, those secret services don't talk to us personally, but it's very likely that state actors are already trying to save as much data as possible that is currently encrypted, with the goal to decrypt it once quantum decryption becomes viable. So that means they get the data now, which is now useless but cheap to store, and try to decrypt it later. That's why quantum-resistant cryptography is starting to become enforced, so that this can no longer happen. Pemtext, we're going to hopefully get to that later. So there's an API for that that's in preview. And then just cryptographic algorithms are constantly being improved performance-wise, but also just implementation-wise. Better defaults are picked, new algorithms are implemented. So if you do care about all that, there's another video that Anna made for you, how to handle Java security changes in 25. So go check that out. And if specifically the performance topic was interesting to you, the improvements that I showed there and everything, it's potentially IoT related, Per Minberg has a talk for you, Java Performance Update 2025 from JDK 21 to 25, where he drives into details on that, and that happens on Wednesday. Okay, so quick ad break before I send you off. Java 1 happens in March next year in the Bay Area. I'm going to show you that slide again when you come in if you want to take a photo. Don't go to java1.com right now. It still points at Java at the 2025 edition. We'll fix that over the week. The sessions that I mentioned, do please go to the Ask the Architect sessions session, singular, if you have any questions that I couldn't answer. This will be where Angelos, Paul, Stuart, Per, and Victor, all the JDK folks who are here and who make their living not talking about this stuff, but actually doing this stuff, you can ask them on Thursday morning. And then, this maybe is one to photograph. All these topics are being covered in deeper dives later throughout the week. So if any of those seemed important to you, not all of them I mentioned yet. So if you ask, like, what does this final equals final mean? We'll get there after the break. But just put them all on one slide so you can go to these talks if you want to learn more. And then if structured concurrency, virtual threads, and etc. is interesting to you, there is 4 talks about this in the schedule, some of them very long. So I think Anna and Jose, there's like a 3-hour deep dive. No, sorry, that's a hands-on lab, that's 3 hours. This is a deep dive, that's 3 hours. Then this guy is probably going to mumble a bit. And then Krishna Ravul is going to have something on Friday morning too. So if you're interested in that topic complex, you have tons of choices. Okay, we have 11:02. I would say at 11:20, we meet again. Have a nice break. Okay, welcome back, everybody. Thank you for coming. So I'm going to do the ad a little bit again. Please come to Java 1. We're all thrilled to meet you there. This time I can say we, because I actually do contribute to organizing that. And again, those talks, go to the Q&A definitely and the other talks. Okay, now, before we talk about more fancy and interesting stuff, I want to talk about stuff that the JDK team is taking away from you. Now, as I said earlier, just when I had a conversation here, the flip side of me not taking credit about their work is also I don't have to take the blame. So now clearly they are taking things away from you. I have nothing to do with that. But I am here to defend those decisions. First of all, if you use any of this, don't. It's gone. Depends on which Java version you're on. You might still see it, but it's already gone in the future. So once you come into the present, then I think I mixed up the timelines. It doesn't matter. The point is, don't use any of these things. They're gone. All the 32-bit ports are gone. The security manager is a hollowed out shell that we're going to talk about in a second. And the update API is also already removed in 26. Okay, let's talk a little briefly about the security manager. It was a system of checks and permissions that is intended to safeguard security-relevant code sections, something that is most important in a situation where you like download code from elsewhere that you're not trusting. We have like maybe plugin architectures, all things that are becoming way less common. And and so that's one of the reasons. I'm going to come to the reasons in a second why it was removed. But this was embodied by the class security manager. It's not the only API that's involved here, but that's like the corner piece is the class security manager. It is not very widely used, but it is maintenance intensive. Since it is a security relevant topic, every time an API or a feature is developed, the question is, how does that interact? Do we need new permissions? Do we need checks? What kind of checks? And so that's a long tail of constant work that security manager came with, which just dragged on the OpenJDK development. And so the important is the combination here. It's not a bad thing if OpenJDK continuously needs to do something if that thing provides a lot of value. It's not a problem if something is barely used, if it just sits there. Something like, you know, vector for, not the new vectors, like vector, the old thing, like Java 1.1 or hashtable or hash table, depending on how you want to pronounce it. Those classes are, hopefully no source code that anybody in this room has written touched on those types, hopefully. But that doesn't mean that that needs to be removed, right? First of all, there's still like bytecode out there that uses it, but also it doesn't harm anybody, right? Like it's not doing anything bad. So the combination between it's not used and it causes an opportunity cost, if anything is in that quadrant, then it's at danger of being removed. It's disallowed by default since JDK 18. If you are on 21, there are certain command line flags that you can use to deactivate it for the future, so to see what this removal behaves like. If you are post JDK 24 and you use the security manager related command line flags, you will get errors. The class still exists so that your code, or specifically your dependencies code, does not need to be recompiled. It is very common for libraries that need to interact with the security manager to do a check. They ask the system, give me a security manager, and if that is not null, then I'm going to do something with that instance. Because in most applications, no security manager is installed, it will mostly be null in most applications. That's why everybody, or all code, in quotation marks, does this check. It first checks, is security manager not null before interacting with it. Now that will always be null. So that code turns into dead code, but will not turn into an exception at runtime. So that's what I mean with all calls are no ops. Basically, everything now takes a stance of there is no security manager. So the class still exists, but the methods don't do anything. It will probably at some point go away, though. So this is the command line flag I talked about. If you're on 12 or later, you can set Java Security Manager to disallow and see what your application will behave like. So if you're still on an older Java version, you can try this out and see what the future looks like. And if you do use it, please move away from it. It is gone. Okay, that was all the list of things that are already gone. Something that is currently deprecated for removal is finalization. What's finalization? First of all, it's the finalized methods that you can put on every object if you want to. And then there's a whole chunk in the Java language specification that describes what happens. And then there's a bunch of code in every garbage collector that properly deals with that. Now, what you need to know is that you can already disable finalization now. And you should definitely do that because it will at some point become the default. The reasons for that is manifold. I probably have links for you later, but generally speaking, finalization is very non-deterministic. Like this method finalize gets called at some point between the object becoming unreachable and the garbage collector having finally removed it. Any time in between, you don't know what the state of the system is in. You can accidentally or intentionally revive instances. It's a bit messy. And it causes constant overhead in work being done in the OpenJDK for the garbage collectors, but also work being done for your application because the garbage collector does need to track this kind of stuff. So that's why it's going to be removed. You can already simulate that removal. What you should do instead is, if you have finalized methods in your code, try with resources. That's the primary replacement that will almost always work. Where it doesn't work, look into the Cleaner API. The Cleaner API has some of the same downsides as finalize, but not all of them. And the ones that it doesn't have make it materially better for JDK, for the JDK to have that one instead. Look for your dependencies. You can use something like JDEPs to run JDEPs command line tool that you can use to mark or to list all deprecated methods that are used in the bytecode that you're examining. So you can, for example, let's say you have a Maven project, you can tell Maven to copy all jars into one folder, all dependencies, And then you can use JDEPs to say, okay, here's my code, here's all my dependencies, list all the deprecated methods that we are using, combine me, but also my dependencies. And then you can report that back, or maybe help the library fix that. I would recommend to run with finalization disabled and then observe your application. Does something strange happen? Does memory consumption suddenly constantly increase? Maybe some resource isn't cleaned up. Maybe you run out of file handles. Maybe you block network sockets. Those kinds of things can technically happen. Observe them. Check it out. And then there's a chunk of changes that fall under the rubric of integrity by default. The idea behind integrity by default is that the Java runtime and the Java language specification, this whole set of specifications makes a bunch of promises that Java mostly upholds. And that is, or let's say in normal mode, upholds all of them. That's about memory safety and about type safety and all these kinds of things that we just use and are used to in everyday life. Integrity now means we want to always, integrity means all of these promises are upheld. But there are mechanisms that undermine this integrity. So for example, you can use unsafe or native code to just change whatever memory there is to something different, right? In that way, for example, you can have something that looks like a string in your source code, but when you call length on it, it crashes because somebody put something else there, for example, just to name something random. So you can usually not write out of array bounds. With something unsafe, you can try. So there's a lot of stuff that breaks, not a lot of, there's actually select stuff, this specifically, that breaks this promise. And the idea here is some of those mechanisms can be replaced with safe alternatives, like unsafe, but other ones, like the bottom three, are still valid Java features that are needed and important. They're not going anywhere. They're just being disallowed by default. That's where this integrity by default comes from. The idea here is to make sure that by default, Java upholds all of its promises. And when you say, no, I'm okay with, for example, dynamic agents to, at runtime, change my bytecode, then that's okay. That's a decision that you as an application operator can make. And then you have to give the command line flag and allow it that way. Okay, so let's go through that list. Unsafe, the methods for memory access have been superseded with var handles and then the foreign function memory API, and they will be phased out. We're currently on runtime warning level, and the JEP that describes this said that maybe on 26, we're going to see an exception on invoking these methods. I'm not sure whether that is currently planned for 26 still. We'll see, I guess. And then those methods will eventually at some point be removed. Unsafe was never a supported API, so everybody who used it, hopefully, willingly, but more likely, not exactly that explicitly, but still basically made a deal and said, I'm using an unsupported API that can change at any minute. It is changing. You're probably not using it directly. If your dependencies are using it, make sure they're aware of this and change things. You can use sunMISC unsafe memory access and set to some of these values to figure out what's happening. I would, again, recommend to set it to deny to the most aggressive option, see what fails, and then make sure to report that and maybe help fix it. Let's talk about final fields. Non-record final fields can actually mutate it through reflection. If your class has a private final string first name, then that looks like can only be assigned once, but that's not actually true. Everybody who can use reflection can call set accessible true and then just change the value, which can potentially cause correctness issues all the way down to maybe even security implications. But maybe more importantly is it just doesn't allow for certain optimizations that you would otherwise hope you'd get, specifically constant folding. So that was probably not great, the decision to allow set accessible to do that. Specifically in hindsight, there's a historic reason why. It's in the context of serialization, which is own can of worms. So a future Java version, and at this point it's not known which one, a future Java version will require an option to allow final field mutation. So just so you're aware of this, at some point we're going to meet again next year or in 2 years or in 3 years, I will tell you the same thing I just told you with unsafe. There is now a command line flag where you can blah, 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 and then you can simulate the future and please move away from code that does this. This is just a warning. There's nothing specific in JDK 25 here yet. This is specific though. Native code can also undermine Java's integrity, and every application owner should, again, do this knowingly should basically make that trade-off. And that's fair, right? I'm not saying JNI is bad or FFM is bad for doing this. It's just the nature of the thing. Java hands control over to native code that it has that the JVM has no control over, that can do whatever. So naturally, it cannot make any guarantees. And if you need the native code to do a thing, that's fine. Then you have to allow this, and that comes with the obligation or with the implied contract that you now take on that responsibility, right? That you check with that library, that you make sure it's at least up to date, that you trust those developers and all that. In the future, you will have to use enable native access to allow specific code to use some of these restricted methods. For now, there's also an overruling flag that is temporary that says, okay, for every code that I didn't specifically allow it to, just let it do either allow or warn or deny. Details are in the JEP. The idea here is that the bottom one, the general purpose one, will go away, and you will at some point have to explicitly allow this for specific code. By the way, this is also something where modules become more essential. Many of these flags, like enable native access or add exports or something like that, they allow code that is in a specific module to allow it to do a specific thing. And then the runtime will make sure that every code that is not in that module cannot do that thing. If your code does not run in modules, the only option that you have left is to allow it to all code on the class path. That means it's a difference, basically, right? Whether you like open a small window to your house or just like leave the front door and the garage door open at the same time. So the idea behind enable native access to this module is that, yes, some code, like maybe native code can potentially cause issues for me, but I only allow it to this module and I've checked that it does good things. But if you have no modules, if you have to say allow this to every code on the class path, then all other code that happens to also be on the class path can potentially abuse that opening, intentionally or accidentally. Okay, so you can use illegal native access. You can set it to allow, warn, and deny. Since JDK24, warn is the default, so you get like a little warning block, like, hey, this method is using this JNI method, which you have not allowed. As I said, in the future, deny will become the only mode. Okay, agents. We talked about this briefly earlier, and with some questions that we had here as well. An agent can do a bunch of things, but one thing it can do, it can transform bytecode. So it can take the bytecode that is loaded and just change it wildly, which is cool, right? It can do cool stuff. We just talked about OpenTelemetry. What that one, for example, does, it injects all kinds of things into your methods so that you can measure exactly how long is which method executed. You can trace things like this specific request, which methods did it end up calling. Nothing bad about that. But it means it can do whatever, and whatever may not be necessarily in your interest. So again, dynamic agents will be something that you will have to enable to basically make that trade of saying, okay, this might be, I'm not getting the all integrity promises anymore, but it is worth it to me. So all mechanisms for agents remain intact and nothing changed yet, but in the future, this dynamic attach will be disabled by default, and you have to say, yes, I want to allow attaching a dynamic agent later at runtime. Agents do not have to be attached at runtime. They can also be configured at boot time, at launch time, and that already requires a command line flag. So that already basically tells you, okay, I have to put this command line flag here, so I'm basically opting out of this. You can already -enable, also known as disable, dynamic agent loading, and then you can see whether your app still behaves as you intended it to do. And if you find out that you have dynamic agents, investigate their necessity. There was something I just wanted to say. I'll probably come back to me. Oh, right, yes. If you find something is not working on with one of these dependencies that maybe use unsafe or that use a dynamic agent or whatever, and you search for the solution, right? Or maybe you ask Guy for the solution. And somebody says you, some documentation says you, oh, just add this command line flag. Be aware that something like add exports that enable dynamic agent loading, allow unsafe, allow JNI, all of those things are valid solutions that are at your disposals, but they are not zero consequence solutions. You are making a trade-off here. You are intentionally saying, this kind of integrity is not that important to me. This other feature is more important. Make that willingly and knowingly. Don't just read in some README, oh, add this command line flag and just do it. Projects, from my point of view, projects that really try to sweep this under the rug are being dishonest with their users. It's important that they clearly present their trade-offs. And I think if you have a project that provides value to your users, I think it's an easy statement to make, to say, hey, this is what I offer, this is what you have to configure, and you give up something. I think it's worth it. But just saying, oh yeah, add this command line flag, it'll be fine, I think is somewhat dishonest. So make sure that whenever you see that you processing that these command line flags do express an intention that can make, for example, might mean that your application becomes dependent on a specific Java version, that updates become more complicated. It could have performance implications because maybe you're giving up some guarantees that then the just-in-time compiler cannot build on. In the extreme case, you might have unreliable or even unsecure situations occur because of that. None of that is terribly common. I'm not trying to scare you. I'm just saying it's a conscious choice that you should make and not just accept somebody's README and just add command line flags willy-nilly. Okay, there were a bunch of JEPs mentioned before that you can all click on. There's a JEP draft that goes into much more details why integrity by default is so important. Also made a video about that if you prefer that. And then because this often comes up in upgrade situations, the videos I make for upgrading from 17 to 21 and from 21 to 25 also talk about this. Okay, so you came back from your break. We had this ad break. We talked about the removals. Now it's finally time to talk about fun stuff again. So we have 50 minutes left, which will not be enough to talk about all that, and then also potentially all that. So we did the same thing. I'm going to do the same thing I did in the last couple of years. You can pick. So since I have no real voting mechanism, I will just let you yell, and whatever I hear the most or the loudest, I will just do. So this is preview features, by the way. That's why these are like with a little plus. Oh, I definitely want to get to structured concurrency at some point. So if you're interested in that, don't yell it. We'll definitely do it at some point. And then we have all of this. So what do you want to talk about? ZGC. GGC. Okay, there we go. See, that's how easy it is. Okay, let's talk about ZGC. I think this was pretty short, by the way. So get your guns ready. You're gonna have a second chance soon. Okay, ZGC, the Z stands for the same thing that, and there was an operating system that had a Z as well. I forgot. It's nothing really. Like it's not zero. It's a meme basically. I think like a very nerdy operating system meme. ZGC compared to other garbage collectors optimizes for ultra low pause times. Every garbage collector trades something against something else. There is no garbage collector that has no overhead. And no pause times. And there's a third category that I just forgot. So, all right, and no CPU overhead, no memory overhead, and also no pause times. It just doesn't exist. They're all optimized for different things. G1 sits a little bit in the middle there. Parallel GC is something you might have used for batch jobs, or you might be using for batch jobs. It used to be the default on most hardware. The actual default depends a little bit on how much memory you have available, but generally speaking, G1 is picked in most situations as the default. Now, in Java 8, it was still parallel GC. Parallel GC doesn't care about pause times. You can get multi-second pause times with it, but it has extremely good throughput. So if you have like a nightly batch job, use parallel GC. If you have actual users waiting for something to happen after a click, then maybe don't, because they might get angry if they have the occasional 5-second break. And ZGC specifically optimizes for ultra-low pause times. And that means it can have higher memory footprint and CPU usage. And then in JDK 21, ZGC became generational. Generational garbage collectors built on a generational hypothesis, which says most objects die young, and those who don't usually grow very old. And if you just let your intuition play a bit, you can actually see that. Let's say you have a web backend, right? You know that there's a bunch of, let's say you have a Spring backend. There's a bunch of classes that Spring just initializes and boots, all kinds of beans and whatever, right? And it creates them when you launch, and will probably keep them for the entire runtime of the application. And then whenever a request comes in, you go to the database, ask for a user, and now you have a user instance. You do a few things with the user instance, you reply, you send a response out, and then that data becomes old and unused, right? So not old, sorry, it's still young, but it becomes unused. So you can see this dichotomy very, just by intuition, that makes a lot of sense, right? So most objects die young, those who don't grow very old, and GCs can make use of this by tracking a young and an old generation and then optimizing differently for those different things. And ZGC didn't do this, but can do it now for a while already. You might have seen this before.
I got slammed somewhere, and I think in YouTube comments, for just showing a graph out of context. I'm still doing it because I link to the context up there. I'm not, again, giving you these numbers to make you promises. I'm showing you these numbers to say things get better. That might be worth it for you. So this is from Netflix, who adopted ZGC very early and aggressively, and I'm super happy with it. The gray line is historic data. The blue line is current data, and you see a little dip here at the end. That's good. It means less. Now let me see. What was measured here? Memory. Yes, less memory use. So a little less. What is it? I don't know. Maybe 10%. Details don't matter. You can hope for less memory consumption. This one is really cool. This one measures GC pauses. So this is historic data, and then they switch to ZGC, and this is not the end of data collection. This is all the lines go so close to 0 you can't see them anymore. So that's good, I guess. So they were happy with that. Generation mode is the default on JDK 23, and now the only mode on 24 and later. So if you want to try ZGC, you still have to activate it because G1 is still picked as the default collector in most situations. There's no situation where GGC happens on its own. You need to always turn it on, but you get the generational mode for free. So specifically, if you do run web backends and you do want to minimize pause times for users, and then not just for users, maybe also you have several services. That's one thing that Netflix observed. It's not only dropping the pause times, which is beneficial to users, it also means that services that are under high load internally have less flukes and will then cause fewer upstream errors, right? So if a service calling a service calling a service and the last one has a pause, that also means that the service in front of that might not get the response in time and might trigger error behavior or whatever, or switch to some other service. So that made the overall system in the observation more reliable. So yeah, if that's interesting to you, try this out. As I said earlier, everything performance related, you probably have some way to measure the outcomes of that. Stefan Johansson on Thursday will give a talk about that. Not only GGC, but also the other garbage collectors. He will talk about what their strengths and weaknesses are, how to pick which one, and also how the performance got better across different Java versions. So I can highly recommend checking out that talk. Bunch of JDK enhancement proposals, and also bunch of videos. This one is, I think, the article from Netflix, by the way, if you want to read that. Okay, that was it already. That was GGC. We're back here. Stream gatherers, yes. Unnamed, was patterns? Okay, unnamed patterns. Let's go with unnamed patterns. And then we do stream gatherers, and then I do my structure concurrency, and then we'll see how much time we have left. Okay, unnamed patterns. Okay, so you can now use the underscore to mark a pattern variable and also lambda variables that you don't want to use. So for example, I have here a buy consumer. I don't know why. Maybe some API forced me to use a buy consumer, but I don't really need the second variable at all. So instead of putting something there, just put an underscore, which expresses to me and to my colleagues, I don't need this. It also expresses to the compiler, I don't need this, which is good, because not only do I not get unused variable warnings, I also can have several underscores in the same scope. I can use this several times, and then I just use S there. Here I have a record called user that has a name component and another component, don't know which one, also don't care, so I use the underscore to take the record apart into just the name, and I don't forget about the other one. Here I'm switching over an object, and I do want to know whether it's a user or an admin, apparently to count something, but I don't care about the instance itself, so I use the underscore. And if I only had like 30 seconds to introduce this feature, I would be done. This is all this is. Whenever you don't need a variable, put an underscore there, expresses your intent clearly, and also make sure that that you can, well, not make sure, but you can also use this several times. So funny little backstory about this. I've told this before, so if you heard it, you have to suffer through it. But Java 8 introduced lambdas. And at that time, they were like, maybe we're going to use the underscore for exactly this. But it used to be a legal variable name in Java. So they deprecated it, which I missed, I didn't notice. And then, because who uses underscore, right? And then when Java 9 came out, they actually forbade it. So you could have variables with a single underscore on Java 7, and then that code would not compile on Java 9 anymore, which is crazy, right? This doesn't happen very often. I heard about it when Java 9 came out, And the explanation was, well, we're deprecating this for removal, or we rather removed it in 9, because then maybe we can use it in situations like this. And I was like, oh yeah, I'm in situations like this. Like occasionally at least. Shit, the single underscore is gone. Let me use 2. So I started using 2 underscores in situations like this, which you can still do. That is still legal variable name. The issue with that is if you then have a nested scope and you need one more of those, because that's a variable, right? So you cannot use the same name. So then I had to go to like 3 underscores that only happen like once or twice. So the good thing about the single underscore is you can use it in the same scope several times. It's not really a variable. You cannot reference it. You can do underscore dot toString. You cannot do underscore dot toString. Like underscore, it's not a thing. It just means I don't need this. Okay, that last point is kind of important. So we're now going to take like a 5-minute detour to explain why that is important if you do pattern matching on Java. Let's have a simple app that crawls GitHub and that creates instances of this page type, which is an interface. This interface has these 4 implementations. And then something happens with those pages. What happens? All kinds of things could technically happen. Display, like, we're crawling GitHub, so maybe we want to see like an interactive graph or want to compute some properties, maybe want to charge for this, so we have payment processing. You can see how this essential type could be used in a lot of different contexts, right? Everybody in the subsystem wants to somehow do something with this page type. So how would we implement that? Well, a simple solution would be to just put all those methods on page. So then page has do graph analysis, paint yourself onto a context, deal with the payment subsystem. And if now your skin is not crawling, then you have not done software development long enough. Because it's terrible, right? You don't want to do this. Like, you don't want to have all of these different use cases collide on the same type. So visitor pattern is one solution here, which, can be the best solution. I've worked in a code base where it was used a lot because it was the best solution, but it's also very annoying and hard to wrap your head around, specifically as a newbie, but also makes it really hard to track what is happening. In comes pattern matching. Pattern matching consists of a bunch of different features that we're now going to all put into practice very quickly. The first step is you take this page interface and you make it sealed. And that means only specific types that you allow are allowed to extend or implement that interface. And then that's important to you and other humans reading that code, but also to the compiler. We'll get to that. And then you implement all features. All these things are not methods on the page type. They're all methods elsewhere that get a page type, a page instance handed to them. So you take this page, and then you say, well, for the pull request page, I want to do this, but for the issue page, I want to do something else. And so you do that with a switch. And the important part is you do avoid the default branch for maintainability. So let's quickly go through this. I have my sealed interface here, and I permit these exact 4 types that I need: issue page, pull request page, external page, if somebody links to Wikipedia or something, and error page if 404 or some other problem happened. Okay, and now this is what I do. If I have to call categorize, for example, that's what I'm doing. I'm trying to categorize the different the pages here. I do not have a categorize method on page, because then page knows the category subsystem, whatever that is. No, it's the other way around. The category subsystem gets a page handed, switches over it, and depending on which instance, which type it is, so which type the instance is, I'm using something different. I'm doing something different. Okay, so far so good. This is the whole pattern matching over sealed types kind of thing that we're doing. Sometimes I do want to have kind of a default behavior. So let's say here, I want to only categorize GitHub pages, but not the error page and not the external page. If I write code like this, it's incomplete. Like you can see if an error page comes in, what do I return? Like, what happened? There's no case for it. So what could possibly be returned? Technically null, well, that would be so broken, so that's not the case. So instead, this doesn't even compile, because I'm not handling all cases. The compiler forces me to handle all cases. So that is a difference to an if-else-if chain, right? Like an if-else-if chain does not have to cover all cases. I mean, if you have to return, it eventually has to, but generally speaking, if you have statements, you can just forget to cover a case. Switch doesn't allow that. A switch over like a pattern switch is what I call it here. So a switch over a complex type like this needs to be exhaustive. It needs to cover all possible cases. And there's 2 ways to achieve that. One of them is to add a default branch, right? If you add a default branch, then all cases are always covered because whatever comes up, if it doesn't have a specific case, it can go into default. But you can also have explicit branches. If you switch over a sealed type and you mention all possible subtypes, then you're also exhaustive. So option 1 is this. Option 1 is, well, I only categorize the issue page and the pull request page, and everything else is category none. Okay, good. Now, we want to add the GitHub commit page. It's Friday afternoon. We have just been told that an important customer wants this thing implemented. So we add this type. And now, this code still compiles, right? Because it just heads up in the default branch, and so it gets no category. And that will lead to an early Saturday morning. So we don't want that. We want to have a compile error because we added a type that we should be using, that we should be, sorry, not using, should be handling here, right? Because, so the idea is that the page interface is somewhere here and the category subsystem is somewhere else, so it's not obvious that you need to make that change. Okay, so option 2 in Java 21, when I want to list all the subtypes, would be this. So I have to list all the subtypes explicitly. There's a little bit of code duplication here, which is ugly. We're going to get to that. But this works, right? Now I have all 4 types listed. And now if a 5th type shows up, the compiler can tell me that the switch expression does not cover all possible input values. I do get my compile error. That's the same thing that the visitor pattern gets me. It means if I add a type and I follow the chain of compile errors, I will eventually have to update all operations that use these types. This is the same thing I get here, just without the indirection. Okay, so that's good, right? So this is what I want to have. But the duplication, it still hurts. So what can we do? Wouldn't it be nice to do this? Wouldn't it be nice to combine these 2 branches? No, I mean, kind of. But the reason why it doesn't work is because that branch doesn't make sense. This is implicitly an OR, right? You're saying if page is an error page or an external page, then do the thing on the right-hand side. But if I do this, then can I use this variable, err? No, because it could be an external page, right? It wouldn't even be this variable. Can I use ext? No, because it could be this other one. So having these 2 variables declared here makes no sense because I can never know which one is actually which. So that's why it doesn't allow that. They're not in scope because they are only in scope where the compiler knows that, yes, it was of this type. Because this would be nice to combine branches that way, but it doesn't work because I basically say I need a variable of this name and a variable of that name that are of that specific type. And now we come back to the underscore. With the underscore, you can do that. With the underscore, because you do not care about the variable, right? You don't care whether it's an error page or an external page. You're not using the variable anyway. So this now is provably correct, right? The compiler knows all 4 cases are covered, and you can combine these 2 cases because none of the variables are used on the right-hand side. So you get this kind of default behavior without a default branch. It becomes a little bit more verbose by having to list the remaining types, but at least you don't have to have like one full branch for each. And this is why this tiny little underscore was actually one of my most awaited features, and I was really annoyed that it didn't make it in 21, because if you do want to do pattern matching over sealed types, the whole data into a programming path, then this is important to do this. It is important to cover all cases without a default branch, and having the duplication there was really hurting. So, I mean, not hurting, but nobody wants that. It doesn't look good, it doesn't read well, it just feels bad while doing it and writing it. This is why this underscore is more important than just if you don't need something, just use the underscore. It's specifically, you can now cover all cases more succinctly and more expressively. Angelos Bimpoudis, who developed pattern matching features, he's also involved with a preview feature that is currently in JDK 25 with primitive patterns. He's going to give a talk on Thursday about pattern matching under the microscope. He will tell you more about that. I'm not sure whether he still gets back to the underscore. For him, it's pretty old news at this point, I guess. Okay, good. If you don't have questions, I'm going to go to stream gatherers. Mario, yes?
Yeah, that looks similar to me, but with a different syntax of what you do in a catch block. I mean, you can catch type of exception with a pipe with a there.
Yeah.
And actually, you can also use the variable. You can also name the variable.
Yeah.
So I don't understand why they use different.
Okay, the eagle-eyed observer spotted that Java has this one place where you can say, oh, it's this type or that type. Java never allows that anywhere. Well, you can kind of like, you can trick generics into doing that. But there's one place where you can do it, which is a catch block. In a catch block, you can say, catch this exception or that exception or that exception, and just make it one variable. I don't care which one it is. So the reason why that works there is because you have a top-level type to escape to, right? You know it's always of type exception. So basically, you're declaring a variable of type exception, but you don't want users to write exception, because if they write exception, then all the exceptions are caught, but you probably want to have all the other ones just fly through. And this is actually kind of similar. You can write case page, like that type, that page type. You can write that here, that works, case page. It works like a default branch because, well, every new page I add obviously is an implementation of that page, so all of them obviously get caught down here. Now you could argue that if I write error page, pipe, external page, page, and then arrow, that would also have worked and be more in line with the way exceptions work. Maybe that's a question. Brian isn't here. He would be a perfect person to ask that. I'm wondering whether if he would redesign the way exceptions catching works, he would still pick that old way with the pipes. Okay, gatherers. Stream gatherers. Okay, I like using streams. When I still worked in a project that people had to regularly work a lot with my code, they would all tell you I liked them too much. I thought they were great. I spent way more time than I'm willing to admit trying to make a for loop into a stream pipeline, only to realize at some point it doesn't really work. And then some of the time I reverted and I was like, no, this beast was like twice as long. It was like, it will stay here. But that's good. I mean, not good to leave it in there. But I think when a new API comes out, I think it's totally viable to take that and just push it as far as you can. And then sometimes you just sit there and say, okay, this is too far. But that's good because that means it gives you an intuition and a feeling for what is too far and what is a good spot for the API, right? So I invite you, if a new API comes out, to yes, do use it and push it and abuse it, but always listen to the feedback you get, to what people work with your code tell you about it, and be willing to revert, but take away from that what works. And here, probably primarily, you yourself could probably decide, okay, this went too far. And one of the reasons why I couldn't turn every for loop into a stream operation is because there are a bunch of operations that are kind of missing. Things that you would want to do, but that you can't. So for example, let's say sliding window is a simple example. You have a stream that has elements, and what you now want to do is you want to slide a window, let's say, of 3 elements over that. So in the new stream, the first one is the first 3 elements. And the next element is that window shifted. So it's element 2, 3, 4 in a little list. And the next one is element 3, 4, 5 in a list, right? So you want to have the sliding window. For example, one thing. Or fixed groups, you want to turn your stream into groups of 5 elements. Stuff like that. All of that is missing. There are also arguably some terminal operations that are missing from the Stream API. But the Stream API did have an escape hatch. So it took the idea of what could happen at the end of a stream and turned it into the concept of collectors. So specifically, there's an interface called collector. There's a bunch of implementations that already exist on collectors. Remember when you still had to do when you had to write collect collectors to list, that terrible thing we don't have to do anymore. Right, so that's where collectors come in. And then you would pass them to a collect method. And the idea behind gatherers is, let's do the same idea, but apply it to intermediate operations. So specifically, let's generalize the concept of intermediate operation, like what could happen there, to the concept of a gatherer. Then there's also an interface that goes with that. And then there's a bunch of implemented gatherers on this class, on this helper class gatherers. And whether it's that one of those instances or it's something you implemented yourself, you pass it to stream gather, and then something happens, right? So for example, here I'm having a stream of these letters. I'm calling gatherers.scan. Doesn't matter what it does. I'm just doing, oh, this is not, no IO print line yet. So don't laugh, or I'll fix it, and everybody has to wait while I do it. So yeah, so whatever this gather doesn't matter. The point is, this is how I use it. I call the gather method, I pass scan to it, and then it does its thing. Okay, a gatherer has a bunch of building blocks. Only one of them is required, which is the integrator. The integrator is called with every element. So every element that is in that stream gets passed to the integrator one after another. But not only that, it gets two additional arguments. The state that we're going to skip for now, and a downstream. The downstream is basically the next stream operation that comes after. And the idea here is that the integrator looks at an element, does something with it presumably, and then puts it into the downstream. And it can use the state for that. As I said, we're going to skip that for now. And it can also signal when it's done. Okay, so let's take a look. This one does nothing. I call it transparent. The gatherer takes elements of type T. This is the state type. Again, we're ignoring this. And it pushes out elements of type T. And what it does is it takes the ignored state, see, underscore, the element and the downstream, and then just says, push the element downstream. And so nothing is happening. And that's the integrator, and then we say return gatherer of integrator, and that way now we have a gatherer, right? So everybody can now call gather transparent and have a no-op in there that doesn't do anything. If you go into gatherers, I can highly recommend to start re-implementing a few Java APIs. It's a fun way to get to know this specific API. Now, this code often doesn't quite compile because you need, or either you need, or at least in many situations you would benefit a lot from wildcards. But putting question mark extends and question mark super all over these slides is really not helping anybody. So that's why I'm not. But yeah, like if you copy paste this, sometimes the compiler would complain. I think this one would actually work, but you would still have probably a super here and extends here. You'd want to have, I say. Okay, so this one does a map, right? So this integrator takes a state that is ignored, the element in the downstream, then applies the function that I passed into the map to the element, and then the new element I pass downstream. And what we can also see here that this push method returns something, returns a Boolean that says, does the downstream operation want more instances, want more elements? Right? Maybe downstream is a find first and we're already done. So it can signal this up the chain. If you don't treat this signal correctly, you might do some unnecessary work. You will not create broken results, but it's a good practice to handle the signal properly. Okay, good. So this is re-implementing map. And we could keep going with this, but instead I want to show you the other three building blocks. They are initializer, finisher, and combiner. Initializer initializes an instance of the state that we have so far ignored. And then, as I said, the state could be, we're going to see an example, I hope. Yes, we see an example. The initializer creates an empty state that then the integrator can update. The finisher runs when the entire operation, so when the entire stream operation prior to it is done, when all the elements are processed and still more elements are requested by the downstream method, by the downstream operation, then the finisher runs once. It doesn't get an element. It just has the state and the downstream and then can emit more, which is very important. This is like not having this is the main reason why you cannot implement all the other stuff that I showed you, because some of the things that I wanted to have, like sliding windows and whatever, you could actually implement that yourself in a very broken kind of like map way, for example. But this operation was missing. Like you never knew when the stream was done, and then you could never like process the last state that you had. I'm going to see in a second actually how that works out. And then the combiner is only needed for parallel streams. So if the reason why the initializer does not return an instance, or rather, the reason why you do not return an instance of a state, but return a recipe that creates an instance of a state, is that when parallel streams run, then each portion that is run in one thread creates its own state, does hold the integration, and then at the end, all those little bits of the stream that were run in parallel, all those states will be combined all the way up to the top, and then the finisher will run once with this consolidated state, which for basically all the example operations I came up with does not make sense, because all the examples or all the code that I ever needed actually for always runs, only makes sense on sequential streams. Okay, good. Let's do something. Let's create fixed-sized groups. The idea is I have this sequence, AC, FBS, and I want to create groups of 2, which gives me AC, FB, and then S as the last element. What we need here is an initializer to create an empty group, which will be a list. Then the integrator needs to put stuff in that list, and when it's full, emits the list. And then the finisher needs to just emit the incomplete group. So the supplier is easy. A supplier of list is just array list new. That's the first portion. Second part, integrator. Okay, given this list and the element and the downstream, first let's add the element to the list. And now we're checking where are we at. If we are under size, we're going to say I need more elements. And if we are at size, we're going to create an immutable copy, clear the mutable state, right? That state is always mutable. But remember, in a parallel stream situation, every thread has its own, so there's no multi-threading concerns here. And then you take that group and push it downstream and return the result of this push. Actually, since I made this example, I realize right now I didn't update it. You can actually ask the downstream whether it's rejecting. I'm not sure whether that can ever change, but yes, you can ask here, DS is rejecting if you wanted to. Then you have to invert that result. But never mind, it does the right thing. Okay, so that's the integrator. Put stuff in the list and either wants more elements for the list to grow or pushes a copy of the list downstream as a group. And now the finisher does this, which just takes the group and pushes it downstream. And does anybody know where the bug is hiding? I'm not returning. That is, no, it's a by consumer. I do not need to return because it's the end. Like the finisher runs, there's never an after the finisher. So I don't need to signal, do I want more elements or not? Empty list, yes, exactly. So if I happened to have cut the initial stream into pairs successfully, then the list could be empty at this point, and that's not good. So yes, but other than that, this also does the right thing. And then I take all of that and I say gatherer of sequential. So then the gatherer has some meta information that tells the stream pipeline, you cannot run this gatherer in parallel. You have to run it sequentially. Which, you could argue, I don't need to do this, right? Like maybe groups need to be sequential groups. Maybe if I want to have a parallel stream, I don't care what order the groups are in, as long as I have groups of that size. You could actually argue, no, this operation could totally be parallelizable, in which case now I would need a combiner that takes all the remaining states and puts them together, and then the end maybe notices, oh, I still have like n elements in the list, so I still need to go through and push out all the groups that I have of the right size. Okay, so we use this now. This is what I get: AC, FB, and S, and those will be individual lists. And if you do on a list.off or list.copyoff, you do a print line, you get this square brackets thing. So that's what that would look like. Venkat is going to give a talk in this room after the break about extending functional pipelines with gatherers. So if you're interested in more on that, then do check out that talk or that deep dive. And then also I had a bunch of videos on that. The last one I really enjoyed. That's just me, implementing all kinds of operations with gatherers. Although there is still, for example, I think the return of the push, for example, simply not handling that correctly. They all work right, but they don't use the API optimally, but correctly. Okay. This monitor is about to turn off in a minute. I can't do anything about it. It's not a touch screen. Hey, that worked. Thank you. Okay, good. I want to talk about structure concurrency, and then we go back to the selection. Oh, no. Sorry. Oh, wait. There we go. Okay, structure concurrency. Let me take a sip of water. This is not the only way to organize concurrency, but it's a not uncommon way at least. You have some executor service instance, or maybe several of them, that just come up early in your program. They just exist. And whenever you want to do stuff concurrently, you just go there and just like, do this for me, please. And then you get back something like completable future. And then, wherever you feel that's convenient, you just add some computations after there, right? Like, okay, so when this is done, then do this, and when that is done, then do that. And then somewhere else you say like get, and you wait blockingly for the result. And that's not inherently wrong. Clearly it works, right? We've written a bunch of code like that. But one property that it has is that concurrency is all over the place. Quite literally, concurrency is happening in many different cases in your code base, right? Completable futures are coming and going. You're never sure where exactly you're blocking and waiting for. I mean, if you look at the code, you see, oh, this is a get call, so this is blocking. But in advance, when you just see, okay, where's this computable future going, you're never sure at what point in your program somebody's waiting for that. So it's not easy to analyze. So you have really a hard time to express in code or identify later when reading the relationships between these threads. If you want to have overarching result or error handling, that is not trivial. Analyzing the control flow, like just looking at the code and see what goes where and how does it come back, is also not trivial. And this becomes particularly important when you want to debug stuff, because more than once have I sat in a, like had a breakpoint, I looked in thread dump, and then you go up the stack trace, and then you end in some method that is launched from a thread pool. And you're like, okay, great, but what was the context? What was like, who did this? Like, where does this task come from? Which is, can be hard to find unless you add more code and more tracing information. We have been in a situation like, in a similar situation like this, or maybe in an analog situations like this before, with gotos. So gotos always, like the idea like with concurrency being all over the place, also control flow used to be all over the place, right? You could just go from ever to wherever with gotos. I mean, not that I remember that, that was way before my time. But that's a thing that I heard. Also, Dijkstra wrote this article about Goto considered harmful in the end of the 60s, and he coined the term structure programming, which back then was fought back hard against. The idea that, wait, I cannot just do whatever I want wherever I want, that sounds terrible. There was an actual argument to be had, because initially it makes sense. You're limiting the amount of options. How is that a good thing? But it is a good thing to prescribe single entry and clearly defined exit points, because it makes code easier to understand. This was so influential that entire languages and language runtimes and concepts were built around that, right? Like for me, it's crazy to think otherwise. This idea that I just write statements and then at some point I just make pointers that go elsewhere just seems ludicrous to me. We also used to like the concept of methods and control structures and everything that we just inherently believe, yes, clearly this is better, right? And the idea now is that maybe a similar, also clearly not that strong, but maybe a similar case exists for structure concurrency. This is the phrasing that Project Loom, which introduced this or is introducing this, is using. When the flow of execution splits into multiple concurrent flows, they rejoin the same code block. Show you that in a second what that means. But the term was not created by Loom. That's Martin Sustrick and Nathaniel Smith in these two blog posts coined and then refined the term and really put this idea on the radar of maybe concurrency should also be more confined to a single place. And so JDK25, as a preview API in its 5th preview, has this API. Okay, so what's going on here? I'm opening a structured task scope. Structured task scope is kind of, you can think of it a little bit like an executor service. It's a thing that allows you to fork tasks into new threads. And you use it in a try with resources block because you want it to be closed at the end of this block, right? Because, as I said before, when the flow of execution splits into multiple concurrent flows, they rejoin in the same code block. This is that same code block, this part. So here, I fork subtasks. They happen to be virtual threads, which is good because you don't want to just create threads all over the place because threads are expensive. But it isn't really essential, and it's definitely not needed for correctness that these are virtual threads, right? It's just the great default for this specific API. Okay, so you fork these subtasks. Things are happening. You get these instances back. So basically, these calls return immediately, right? They just kick off a separate thread, and then that thread does its thing, which can potentially take a while. Then we join the scope. This means wait here until, for now, let's say, these tasks complete. We're going to look into detail later what that means. But we're going to wait now for these tasks to complete. And then when we're done with that, we can get those results, right? Because everything is done. And then we can return that. And this thing will throw an execution exception if things went wrong. So you handle the error down there in the to-do. The important part is, right, this is a try with resources block. So that means down here we call close. Or then here or here, depending. But anyway, when we leave this block, we call close. Close will wait for all threads to be done. I mean, in this case, the way this is structured now, both of tasks have to complete successfully. We're going to talk about that in a minute. And that means by the time I'm here, I'm returning from join, they are already done. But there are situations where this could be different. Okay, so what does it mean? First of all, the threads are kind of short-lived. Not short-lived in the sense that this is a quick to-do task, right? Maybe you're doing something lengthy, like making 10 consecutive database calls in one of those tasks, right? With short-lived, I mean, like their scope is short. Like I can easily see where they spawn and where they die. And they end on that completion. And the interesting thing is that something now happening that is not existing with regular threads. We sometimes say child thread, but that's usually actually a misnomer. So when you have in a graph, for example, you have nodes and children, then that means that the child node is like fully contained in the parent node, right? It doesn't have an independent life of its own. But that is with regular threads, that is totally the case, right? You have a thread and that kicks off other threads. Those other threads can run forever long, right? They can run way longer. So there is no like containment. Also thread pools, right? When you're reusing threads, then those threads run indefinitely, so to speak, like they run this as long as your application runs. You pass tasks between them, but no thread is clearly the sibling or the parent or the child of another thread. This is just like strangers meeting in the night and passing messages. But this is different here. The main thread who did all this work and is now waiting here is guaranteed to not leave this block before these threads run out. So now we do have a thread that entirely contains the lifetime of these other two threads. And this establishes a parent-child relationship between that thread and the ones that it spawned, and also sibling relationships between the threads that were spawned together. And this defines a scope for concurrency, the scope in which you spawn these threads and then they return. That simplifies the control flow. When you use this, you will see that you have this one method that basically does all the concurrency, and then those other task methods just do their own thing. It makes it easy to have grouped result or error handling. We're going to talk about that now. But it also makes thread relationships visible. If you do a thread dump with this API, you will see that every child thread actually says, my owner is that other thread. Debuggers don't show this information yet, but that means if in that situation that I described earlier, where you debugging something and you're deep like in a stack trace and you go all the way up top, and then you end up like in the root of that thread, now you're not out of options. Now you can say, what is the owner thread? And that owner thread is probably currently waiting in join. And so you can see, oh, that's what that state is. And then you can go further up, right? Basically, you can, from every breakpoint, wherever deep down your application is, you can go all the way back as long as you're using structured concurrency, potentially all the way up to the thread that is accepting the socket bits or something. Let's talk a little bit about completion. I was kind of vague about that. So how do you do this result and error handling? This is where the joiner comes in. And this is also the change in this fifth review over prior previews of this API, this concept of a joiner. The idea was there before, but it was expressed differently. A joiner is a specific task. It dictates how results are collected, whether subtasks are canceled and how, what join returns, and what join might throw. And you pass an instance of joiner to structured task scope when you open it. So there are two categories of joiners. One is for heterogeneous results and one for homogeneous results. So heterogeneous results means you have different subtasks and they all return something else. You get a weather forecast from the weather forecast service, and you also want to get a user from the database, right? Those are entirely different results. You have two pre-implemented joiners. One of them is await all successful or throw. That means I'm waiting for all of them to be successful, and if any of them isn't, I'm going to throw an exception. That is the default behavior of open. So this joiner exists, but this is the default behavior you get anyway. That's why I was a little waffling earlier. That's what happened there. The two subtasks implicitly have this behavior. All of them must succeed, otherwise they get an exception. You can also do a wait all. A wait all just says, look, you figure it out. I'm just going to let all of these tasks run out, error or not, and then you have to figure out individually what happens. This is kind of like a catch-all if everything else fails. It's uncomfortable to use. So you have the subtask here, just have a single one here. Then join will never throw, at least not this exception. And then you get nothing, like you don't know what's happened. You have to ask the subtask, hey, you have a state. Which of these states are you in? Success, failed, unavailable. If you have several subtasks, you have to figure out a combination. This is something you might want to do when you say, okay, I have like 6 different tasks and there's a wide amount of combinations where I can make it work, and then you have to work through this. But again, this is a catch-all. This is not intended to be used very commonly. Homogeneous results are interesting. The idea here is that you have all of these subtasks return the same kind of result. Maybe you have like 3 weather forecast services that you want to call, and you don't care which one succeeds. Well, that's not true. Maybe you do care, but the point is you always get the same instance back. And you again have these 2 choices. All successful or throw means all of them must be successful. But the cool thing is, if they are, then the join method will actually return something. It will return a stream of result. So you just get, because all of them are the same type, you just immediately get that back out. And then you can say any successful result or throw. That means I don't care, as long as at least one of them succeeds, I don't care what the other ones do. Just give me the first one. I'm fine with that. But keep that in mind. I want to have the first one. What do the other ones do? We're going to get back to that in a second. Okay, so this is an example for any successful result or throw. So I create 2 tasks. I don't need the subtask instances in this case because join will return the result. So join is a method that always returns something. In the cases I showed earlier, it returns void. The return was void, so it always returns null. You cannot use it in the other cases, the return type. The idea is to only use the return in these 2 situations where you say, okay, these tasks both create strings, so let's do this any successful result or throw, and then scope.join returns the one first result that it got. And if both of them fail, I get the exception. Okay, talked a lot about joiners. Implementing them, the API is quite simple, actually. If you want to do something fancy, you have to put all the logic here. So I'm not saying the implementation is trivial, but the task overall isn't terribly complicated. You have an onFork method that gets called. Every time a task is forked, you get that subtask, and now you can do some bookkeeping or whatever. You get an onComplete. So every time a task completes, you get this. Whether it's an error or not, you have to figure out. You have to do, put some logic there. You can signal whether whether the task scope should complete. That's what this Boolean indicates. Am I done? And if you are done, you're going to be asked for a result. And then you either return a result or you throw an exception if something went wrong. And here you can implement all kinds of stuff. Okay. Now, error propagation. What happens if the joiner cancels a scope? Because we had that, right? What if the first result is done? Then the joiner says, we're done. We can cancel the scope, stop computing, we have our result. And then join will immediately return that result. But what happens to the other threads? This is where interruptions become important. The task scope will interrupt these other threads. And then close will wait until they complete. That means these other threads, if they ignore interruptions, whoever caught an interrupted exception and didn't know what to do with it. Or either you're all very smart or you're lying. Okay, I definitely did this. You need to properly handle interrupted exceptions. There used to be a great article by Brian Götz online that is offline because the host of that site did an internal content rearrangement. I'm currently writing a follow-up to that. You need to handle interrupted exceptions properly to make best use of that. And also there is interrupted flag that you might have to ask, to query. Okay. Now we can finally go back to sharing data and scope values. Now I hope this diagram makes way more sense to you. So if it didn't make sense before, I now hope it does. So as I just explained, these child threads start here, and by the end of this block, they will be done, right? The task scope guarantees that they're all done. And that is why this scope is contained in the scoped value scope, and that's why they can pass on the data by default. Okay, I'm a minute over. I don't want to keep you any longer. This is more talks that you can look at about structural concurrency. As I said, like there's a whole day tomorrow that you can have fun with structural concurrency and all that stuff. And then I'm going to talk about this a little bit with code examples on Thursday, and Krishna is going to talk about it on Friday as well. I have a little bit of a Java 20 to 25 in a few slides, but it's just a list of all the features that made it. It's a long list, longer than the rest of the presentation. I want to leave you this one. Java 25 paved the on-ramp further. There's a lot of low-level APIs, like, for example, also class file API and FM API that we skipped that were added. Improves tooling and performance. That's something I spent barely any time on, but the stuff that Billy and Anna talk about in their videos, for example, super interesting. There's Markdown in JavaDoc now, which is really handy. And the AOT workflow and general performance improvements is also something. I can highly encourage you to use JDK 25 first chance you get. It's GA, you can get it there. Thank you very much for your attention. If you have questions, I'll be here for a while to put things together and carry my stuff out. But also, Oracle has a booth starting maybe tomorrow or Wednesday down there. I'll hang out there too. All the other poor folks from OpenJDK will also be there, so bug them with questions too, please. And have a great conference.